Good morning, ladies and gentlemen. My name is Bogdan Piel. I am the General Director of the Polish Chamber of Power Industry and Environmental Protection. With great pleasure, I would like to invite you to today's event, webinar and workshop organized under the honorable patronage of the Ministry of Climate and Environment. The seminar will pertain to issues related to the Polish industry in the nuclear energy program. We call it in Poland the PPJ program. As we know, this program was approved by the government, and it seems that today, as of today, the probability of realizing a nuclear project is very high. The declarations of Minister Kurtyka, the Minister of Climate and Environment, or Minister Naimski indicate that there is a extensive determination from the side of the government to realize this project. Today, we will concentrate, as I said, of course, on the participation of Polish industry, but we can't forget that for public opinion and in general all interested parties interested in the project, there are still questions remaining, mainly to the pertain of the location, the selection of the technological partner, and technology, as well as the manner of financing the investment. These are very important issues, but we are not going to discuss them today because, in the opinion of many experts, the very important aspect of the project is the participation of Polish industry and the benefits resulting not only for the economy, mainly for the economy, but also for many Polish companies. So we say the local content, as we call it. For this reason, we have invited outstanding, excellent partners from foreign companies, European companies, from countries as Belgium, for example, Finland, Great Britain, France, from the United States, from Korea, the International Agency Agency of Atomic Energy, who will present their opinions, their conclusions, and recommendations to Polish companies, but also for Polish decision makers, for the nuclear supervision bodies. So these are issues that are very important. And this is a long-term, long-reaching process. So today's seminar is a subsequent part or element in this constant chain, and I think it'll bring many new interesting indications, pointers, and information, because I believe Polish companies want to participate in, and wanting to participate in this project will have to adapt in their strategies to the new requirements. These are requirements, of course, tied to long-term certification processes, obtaining the appropriate qualifications, obtaining codes, fulfilling standards. So I think that during today's conference, we will be discussing that. The conviction that the project, a nuclear project, and its realization in Poland is important and beneficial. I think that these arguments today, which are for that, are undisputed. The project, first and foremost, because of its safety and security, is very relevant. Of course, we're talking about energy security. We're also going to have large non-emissions generating sources, which is tied to a second very important aspect, and that's environmental protection. And the third is the economic competitiveness of the economy thanks to a nuclear project. I think that the competitiveness will grow thanks to a stable and economic source. So these subject matters today also to a certain degree will be raised, taking advantage of this occasion before the official opening of the substantive part of our webinar. First of all, I'd like to thank very sincerely the Ministry of Climate and Environment for cooperation and in cooperation in the realization of this webinar, especially Mr. Andrzej Szydło's senior expert at the Department of a Nuclear Department, and also the employees of the Polish Chamber of Power Industry and Environmental Protection, and Ms. Monika Silvia, who has contributed greatly to the organization of this conference. I think that it will bring many positive benefits to you. So at this moment, there's nothing left but to invite Mr. Andrzej Szydło, a representative of the Ministry of Climate and the Environment, to bring you the welcome speech and the opening of our conference today. So, Mr. Director, I welcome you sincerely and I give you the floor. Good morning, ladies and gentlemen. Good morning, Mr. Director. Thank you very much for the introduction. I am not the head expert, as clarification, of the Ministry of Climate and Environment, and I would like to thank for the possibility of opening this event. We are meeting today in an online virtual form. Unfortunately, the coronavirus has crossed our plans this year, but thanks to internet connections, such an event could take place. A few words about the nuclear program. This year, the Council of Ministers updated the Polish nuclear program, and the main directional activities are well presented in the press. Nuclear energy, which we indicate in the Polish program, is needed in Poland in order to establish stable and non-emitting sources of energy in the country. And except for those main objectives, we also see in the nuclear program additional benefits which can be achieved, among others, local benefits for national domestic industry by including in the realization of the project in specific areas. Today's webinar is addressed to these areas and subject matters. I think generally speaking, the subject matter is quite difficult and complex because not at the European level or world level have exemplarily models been elaborated in the participation of domestic or national industry in nuclear projects. What we've seen so far is that in different countries the solutions are different. Even in the European Union, we see various examples, whether in Great Britain, industry is involved in a certain way. In Finland, also differently. Spain has interesting solutions, which we believe also can be implemented in Polish economic and industrial realities. Ladies and gentlemen, I am not going to extend too much about industrial issues. We have excellent speakers who will present their international experiences, which we believe can be also transferred to Poland and Polish territory. In short, I would like to say what the role of the government is in this entire process. Because of the fact that the project is large and extensive and will have implications at the economic level to the Polish economy, it is also a long-reaching and far-reaching project. So the participation of the government is important to participate in these economic processes. For some time, we have been realizing activities which we believe and can contribute to the fact that the specificity of nuclear energy is presented to Polish enterprises, so that as early as possible and as smoothly as possible, Polish companies can be implemented and introduced into the project. I would like to say what has been done so far in terms of the industrial aspects of the nuclear project. Several years ago, we did a kind of starting balance, and we analyzed the competencies of Polish industries in terms of the potential for the realization of works for nuclear energy. We examined these processes quite extensively and in depth, and wondering which sectors of the Polish industry can be included in that. What are the barriers of entry or obstacles of entry? What will be certain issues in terms of our national industries participating, also from the level of government. Ladies and gentlemen, in Poland we have various strategies, policies in terms of the national industry, and we see also with the existing programs we can stimulate this sector from the perspective or in view of nuclear activities. For about 5 years, we have two groups of activities in the nuclear area, which we believe are beneficial to Polish enterprises. The first are, let's say, informational training in nature, where we try to present to Polish companies what is the substance of nuclear energy, to bring to Polish company the specificity of standards, norms, codes, the industrial ones, which we believe that when Polish companies are entering this project, especially with the first experiences, they're noting certain problems or issues which they didn't face earlier or prior to that. Year to year, we organize 1, 2, or 3 seminars, strongly technical, in-depth technical, with the participation of foreign experts for a day or two, and those issues are presented. Sometimes as speakers we are successful at bringing in speakers of Polish companies who have some experience and who can be persuaded to share their experiences with other Polish companies. And there were various types of didactical and educational materials which can be downloaded from websites. Perhaps some materials are known to you. We have published materials free of charge which can be downloaded from our partners and industrial and technical partners where we organize these events. These are mainly technical brochures where we try to concentrate on a specific segment of a nuclear project, which is, let's say, in reach of Polish industry or reachable in the next coming years. So we've presented technical requirements pertaining to quality systems and segments such as welding pipelines in nuclear plants, the production of the assembly of various types of pumps, steel constructions, concrete structures, electrical issues. So these many of these aspects has been cataloged also. They are also downloadable free of charge from our website, Poznaj Polski Atom. So get to know the Polish Atom website. And in coming years, we will continue and intensify these activities. And the second area of activities which we are realizing approximately 5 years now is the support of Polish enterprises on the international arena. We see the potential of acquiring such projects and winning such projects by Polish companies are here and now. So even in our surroundings, near surroundings, such as in CEE region or Europe-wide, Polish companies are conducting specific projects for nuclear power plants, and we have the possibility to stimulate these activities year to year. We have done at least 1 or 2 mini missions profiling specific nuclear with the participation of a dozen or so Polish companies. Either it's in nuclear Finland, nuclear Great Britain, nuclear Canada. Twice we conducted a large, at the largest nuclear exhibit at the World Nuclear Exhibition in Paris. Even though it's in France, the half of the exhibitors there or visitors are foreign entities, not French but international. We had a Polish stand, a Polish booth with a number of Polish companies participating, and we also organize workshops in Poland or business forums with the participation of delegations from nuclear industry from abroad. We hosted the Spanish, Southern Korea. We did a large event last year, also from Great Britain or from the US. I think we had about 40 or so Polish companies. These are events that we always invite participants to. We also prepared a catalog. We've mapped Polish enterprises and presented them in Polish industry for nuclear energy. We make that available at very many international events, including our embassies abroad have participated and are engaged in this activity. This would be all from my side. Concluding, I would like to thank you very sincerely, and especially 2 institutions and organizations which have contributed to today's and cooperated in the preparation of this event. The Polish Chamber of Power Industry and Environmental Protection, ENG, which was the source of the idea for this webinar, not only the preparation, but also selecting the subject matter and the participants, the speakers, and also particular thanks to the Viennese International Atomic Energy Agency, which prepared substantively in the preparation of this event. We are going into a project which we are discovering many things which we don't know about many things, and we're taking advantage of the international experience, and the agency from Vienna is contributing to that. We are able to prepare this process from the, for example, involvement of national industry. So thank you very much, and I wish everyone a very fruitful day.
Dziękuję panu.
Thank you, Andrzej, for an introduction to the subject matter of today's conference. Before we go on to the substantive part of our conference, first of all, I would like to sensitize you to the fact that the event is being realized in which Mr. Andrzej Sidło mentioned, which is a remote web seminar, additionally with simultaneous interpretation, and our partners from the Bireta company, so we apologize in advance for any logistic glitches or shortcomings or technical shortcomings, because many things are not up to us. But we hope that we will not be facing any problems or any problems with logging on. I would like to also, in this moment, to ensure all of you that all presentations that will be presented during today's event will be available on our websites. And additionally, during individual panels, there will be a chat available where you can ask questions, and they will be asked to individual speakers. If there is not such a possibility, for reasons of time constraints, for example, we will try to have those questions sent to the speakers and then the answers to those questions available on our website. So now I would like to go on to the substantive part of our conference, which will be conducted and moderated by Ms. Agnieszka Łakoma, a journalist from Forbes. I would like to hand over the leading of the conference to you, Ms. Agnieszka. So I wish all of you a very fruitful day and much new available beneficial knowledge. Thank you very much. Welcome sincerely to today's seminar. I'm very pleased that I would be able to accompany all of you today during the entire day. We've prepared many presentations, and it will be not only interesting, but also very helpful to you. We're beginning with our informal partners, so an individual who represents the International Atomic Energy Agency, which Mr. Andrzej mentioned. I think that this will be an extremely interesting presentation. We have Mr. Dr. Pekka Puu, who is an senior expert at the Department of Nuclear Energy. The title of his presentation is The Importance of Nuclear Quality in Contexts of Nuclear Supply Chain: Codes, Norms, Standards from IAEA Perspective. Welcome, Doctor, and I invite you.
Hello, dzień dobry. I hope you can hear me in Poland or wherever you are. You heard the topic of my presentation, and I will here represent the International Atomic Energy Agency. It's an honor to do that, and this meeting is supported by our technical cooperation funds. To the topic, how does the International Atomic Energy Agency see this area? We believe that nuclear energy, using the words of our Director General Grossi, the agency has to promote sustainable nuclear energy. There are safety standards and fundamental safety principles, but we in the agency Nuclear Energy start our actions from the Nuclear Energy Basic Principles published in 2008 that, apart from the safety principle, also says that there need to be benefits, there needs to be a transparency in nuclear, the resources have to be used efficiently, and there has to be continual improvement. And I think that this very much applies to the nuclear supply chain use as well. Right, so maximizing, we seem to have some glitches in this. So this is the agency role is maximizing the nuclear energy to the world using the words of Mr. Grossi. So what do we see in the area of quality and cost in the world from the agency perspective? So we see that in established nuclear countries, what used to be a strong supply chain is eroding, and there are problems in finding suppliers. This needs to use of commercial grade items, etc. On the other hand, the nuclear supply chain is globalized, and this also gives opportunity for Polish suppliers. Supply chains are longer, less transparent, and obviously some countries want to work on that. The quality assurance requirements, the intrusion is in some cases difficult. On the other hand, and this is what we are discussing today, countries seek for localization and industrial involvement, which is again an opportunity. It comes with certain risks as well, and we are going to talk about that. The codes and standards in different countries, they are different, and this is probably, especially in the area of quality and management system, this is probably one of the biggest hurdles. Technical standards normally companies master, but what is required when it comes to quality, for instance? Supply of services, it's not only the products, but the nuclear program and project needs a lot of services, and this is probably the gray area, and there is more variability. On-site contractors, off-site suppliers, services like safety analysis, the siting analysis. And there are technical challenges, but also opportunities. You have lots of shipyards, for instance, in Poland, so prefabrication of modules might be possible. But then the counterfeiters also have found nuclear industry, so there are more and more counterfeited items, and nuclear is not free from that. There is light at the end of the tunnel. Advanced manufacturing technologies will be available, and the 3D printing, for instance. But people, there are new countries and new generation of people who might be better in the IT, like me, the old generation, but at the same time, maybe the nuclear quality requirements and culture are not so well known to these people. What is the agency doing all about it? First of all, its role, we are a United Nations agency, is really to bring all the countries on the same level. Our SAGNE Special Advisory Group and our Technical Working Group of Nuclear Power Plant Operations, they are guiding us, and they have told us to prepare tools that would be available like toolkits. We are going to talk about it. Luckily, we have got some funding, generous funding from the US, and I use the opportunity to thank the US State Department and DOE for this funding. So we have been able to begin a program on the use of commercial grade items, a publication, but above all, these toolkits that we can use also through the distance in the situation where we have the COVID pandemic on. So these are and will be available to our members. Bring understanding and make it easier for suppliers, owners, and regulators and the governmental bodies to understand what's going on and what they should be doing. Let's talk about the system. There is normally a great misunderstanding here, and unfortunately, the agency has not always been good in kind of bringing clarity in this. The agency started with quality control, and through assurance and management, we have now gone to the level of where we are talking about leadership and management. Now, what is the role of quality in all this? I believe that even our safety glossary uses a bit interesting wordings. Quality, and here you see a lot of definitions. Don't worry, they will be available for you. I just say that quality is the degree to which your product or service conforms with the requirements or needs, and I just hope that they are the same thing. And then the planning, this assurance, proactive part, that's very important. The more important your product or service is, because you might not, in fact, be able to take a failure, for instance, a pressure vessel fabrication. We have been working to, in fact, bring some light in this confusion, and we have recently issued a tech doc that should explain what the role of quality assurance and control are in a management system. And the question is, of course, what is the right level of quality? Not everything has to be nuclear quality for a nuclear power plant, that's for sure. What is the right level of quality? And this might be one of the questions I leave you with. The agency's safety and other documentation follows a certain structure, but so do your national laws, regulations, and guidance and standards. And standards, normally codes and standards, should be left to the contractual level as much as it's possible. And I'm just asking another question I leave you with. I'm sorry to leave you with a lot of questions. Is how does this triangle work in case of Poland? Obviously, the contractual level might have to do with the country with whom you cooperate when it comes to the major supply, the reactor technology vendor, and maybe the main contractor. The toolkit, I might have mentioned, if I haven't, I say it now, we don't expect here in the agency the situation with regulations and standards change in midterm, so in 10 years. The national bodies are sovereign, and different legislations also point towards different regulations. So what we decided to do is to prepare you a toolkit where you can see, especially in that sometimes a little bit less transparent area of quality and management system requirements, what different countries are doing and what is available. So there is a list, and the underlined ones is where we do have regulations, especially when it comes to the manufacturing of products in different countries, and we are working hard to get the others that have not been underlined. Also, when it comes to standards, we have a simple template that normally includes what is found and then points to the page where you, in some cases, can buy the standard. And this is what we have been preparing. And I think that next week there is a launch of the pilot version of this. And if somebody finds something that is incorrect, everybody can contribute to make it correct. The Nuclear Supply Chain Management Toolkit was launched in November, and you can just Google to find it. It needs a login. What does it contain? I showed you what the Regulations and Standards Toolkit contains. The Nuclear Supply Chain Toolkit, first of all, it includes introduction to nuclear supply chain, and it tells you some basic things that everybody should understand. So that's good for a newcomer. Then it tells you which kind of tricks you should do when you prepare for procurement. And I believe that there is very interesting presentation by EDF that also tells about that. Then it tells you about the concepts of the overseeing the supply, hold points, witness points, things like that. And then post-supply chain, receiving factory acceptance testing, reviewing how the suppliers were doing. And then it presents some challenges, areas like the counterfeit, obsolescence, the imperfect design information in the product and changes, digital content, and it gives you a lot of templates and good practices from the member states. So please Google and log in the management system network to get there. Sorry. So this shows you in fact what you should be seeing, and there in the bottom we have this Nuclear Supply Chain Toolkit, and then we will get the Regulations and Standards Toolkit. We in fact have also a contracting toolkit, so there are 3 siblings, and this nuclear contracting toolkit that you also may Google, it's still now in the public domain area and easily accessible. But we need to take it inside here because it's difficult to make changes to those public pages. But please become the member of the management system network so you get access to all this material. And this is property of all our member states, including Poland. Publications, they all are freely downloadable. As Mr. Sitwo said, is also the material in Poland. Please take a look at this important publication, including also the industrial involvement to support of national nuclear power program, but more technical QA, managing counterfeit and fraudulent items, and procurement engineering supply chain guidelines. So these are agency publications. Everybody can download them. And this is not all. It's more and more important in these circumstances for the agency to outreach and to be able to be in contact with the member states. So we have organized a series of webinars, in fact, dealing with the topics of the nuclear supply chain management toolkit. We already had the first one. I believe we had some Polish participants, but on the 16th of December, we are talking about the topic of today as well, requirements to suppliers. Why are they important? Where do they come from? We have 3 outstanding speakers with long experience, and it's good to discuss that. I use the opportunity to say that in fact, how to find good suppliers and how to know if they are good for you. We are planning that for the 14th of January, and then the supply chain management strategy, how to simplify the complex. That will be on the 28th of January, and the registration links for them will become available shortly. For the 16th of December, please register right now. To finalize, a word to Poland. What do you want to be? What you are now? What do you want to become? Normally in nuclear programs, and especially when you go to project, the routine services are bought locally, and this is cafeteria, IT. But then there are leverage with huge cost, and this is also very often done locally, just to show how many jobs this creates. I think that there are lots of speeches about this area coming later by many speakers. And here there are things like gravel, soil transport that local companies do. And then these local companies and people talk for your product, which is very good for you politically and the overall. So brings trust, brings prosperity. No, not yet. Something is happening. But then we go to the market challenge, to bottleneck, which might be electromechanical, INC, maybe safety-related products, where there is a market challenge. And here is where now established nuclear countries are experiencing problems because the original equipment manufacturers are disappearing. And this is an opportunity for Poland. You have lots of industries. I have seen the catalog, and I know that your companies have been involved in nuclear projects. A Polish person told me, yes, but we had bad experience. I tell you, there is no such thing as bad experience. It's all experience, and you can turn it to positive with Poland. You have great potential with your industry, even to be lifted to strategic manufacturers and compete and participate in high-tier supplies with the industry you have in aviation, in shipbuilding, and so on. So this is my final thought for you, and I hope that I have been able to save some time. If the moderator wants, I can of course continue by saying a couple of words what I believe are the roles in this development. But in the meanwhile, Dziękuję, thank you very much for your attention.
Dziękuję bardzo, panie doktorze, za niezwykle interesujące.
Thank you very much, dear doctor, for your extremely interesting presentation, but there's still one more question I'd like to ask you, so if I could please request you to stay with us for a moment. Can you hear me? Okay, so my question would be about the standards that you mentioned in your presentation, because you mentioned that there are quite highly differentiated standards in the individual countries, and my question would be, I'd like to ask your opinion. What is better for Poland as a country that is only starting its nuclear project? Should we develop our own standards, our own quality standards, quality control standards, or perhaps should we rely entirely on the standards and codes of the country that is going to deliver technology to us? What is your opinion on this matter?
Thank you for an excellent question. Before answering it, I tell you something. Truly excellent companies and actors make their own standards. But then from here, I come to the situation of Poland. I think that I mentioned that the codes and standards normally should be left to the contractual level. So many of them will come from the country of origin. However, there is a concept of informed customer. An informed customer, it means that Poland has to take a look at these standards and norms and think what it takes. Here, your legislation has to be taken into account. What does it say about, are there legislative reasons for a norm not to become acceptable as such? The second question is of course regulation. You have to have a visibility and agree on these things with your nuclear regulator, and not only the nuclear regulator, with all the national regulators that can have to do with the nuclear project. I give you an example why I'm saying this, and this is important. For example, in Finland, all the nuclear buildings have to comply with the norms of the industrial buildings. So if the layout rules of for example, the exit routes of a nuclear building do not comply, then they have to be changed. And this doesn't come from the nuclear regulator. It comes from the construction, the civil regulations. So I think that as much as possible, Poland should, of course, use the norms of the country of origin, but with the caveat that you have to see how it complies with your legislation and regulation.
Dziękuję bardzo za tą odpowiedź. Rozumiem.
Thank you very much for this answer. I understand that it would be perfect for Poland to combine our requirements, our standards, also with those that the agency actually indicates, and then we will achieve the ideal, the perfect level of standardization. Is this the path that we should take?
Well, as informed customer, Poland, of course, has to see what is good for Poland. It's the agency point of view that we let all the flowers bloom in a manner that they see good. The agency presents nuclear safety standards, and then we present guidance in other areas and technical reports. I want you to take them into account, but the IEA just presents them in the area of nuclear. There are other, like environmental building regulations and such, that you also need to take into account. And this was my message.
Dziękuję bardzo, panie doktorze.
Thank you very much Thank you very much for attending our seminar. I am so very happy that you found the time and the will to be with us here today. Thank you once again very much. And now, ladies and gentlemen, we are moving over to our next guest. He is already here with us. He has been able to connect. Welcome. I'd like to welcome Tom Greatrex, who is the Chief Executive at the Nuclear Industry Association from London in the United Kingdom. And Tom Greatrex is going to talk about the role of the government, chambers of the industry, local content, on the example of experiences in implementing nuclear power projects in the United Kingdom. Tom, the floor is yours. I hope you can hear us and see us. Welcome. Welcome.
Thank you very much. Good morning, everybody. Thank you for the opportunity of being able to speak, and I hope be able to take some questions on what's happening in the United Kingdom in connection to development of new nuclear capacity. I'm going to give you a little bit of color about the Nuclear Industry Association, what we are, where things are in terms of government policy, and what that means for projects in terms of local content, but also the benefits from building from one project to another as you begin your journey in Poland towards that new city, which is going to be so important for meeting security and climate objectives. So the Nuclear Industry Association is an association of companies that operate in the nuclear sector in the United Kingdom and civil nuclear. We have approximately 250 member companies who are part of the Nuclear Industry Association, and that is a wide range of companies from EDF, who currently operate our existing fleet of 8 power stations in the to through the supply chain, so companies that you will know the names of, like Rolls-Royce and Atkins, Jacobs, etc., through to some very small and specialised engineering companies that might work and have a particular application that's used either in new build or in decommissioning. And that's the employment base amongst our membership is around about 60,000 in the United Kingdom, and they tend to be, in comparison, stable jobs, well-paid jobs, high-quality jobs, and they tend to be around the country, and there's around the areas which are where either the sites or the supply chain is, which means they're not necessarily in London, southeast corner of England, and that's the part of the United Kingdom which traditionally has the highest economic output. The nuclear industry in the United Kingdom helps to, just because of its location, helps to spread the economic benefit more widely across the country. I think I've touched on the range and breadth of the membership of the Nuclear Industry Association. I should also say, which is included on there, our membership also includes those companies that are involved that aren't specifically and specially nuclear, but do nuclear work, so be that in legal and financial, insurance, and advisory services, which are required in nuclear, but people that work across different sectors, but they are also part of our membership and part of we count them as part of the industry. So one of the things that the NIA does is works closely with the government of whatever political persuasion, and previous governments. Since 2008, we've had a policy in the Kingdom to encourage the development of nuclear capacity for reasons of ensuring stability of supply, but also for meeting climate emissions targets, more ambitious and more difficult over the period of that time, culminating in the Paris Climate Accord. And obviously COP20 is going to take place, the postponed COP26 is going to take place in just under a year's time in the UK, in Glasgow. We have a number of bodies which we work with the government on. There's a Nuclear Industry Council, which is made up of a couple from government, the ministries, agencies the industry, and that group is brought together, co-chaired by the Minister and the Chair of the Nuclear Industry Association, which sets the long-term strategy for nuclear and discusses big issues which need to be resolved or dealt with in the process of ensuring we have a healthy nuclear industry. And we also have a body which is the Programme Management Board, works with industry to help to ensure the deal of what we call a nuclear sector deal, which is an agreement between industry and government on priorities for the industry. In relation to new build, that's particularly about driving cost reduction and ensuring that there's UK content in the projects as they go forward. So we work very closely with government on those types of things. We're institutionally partners with the government in those areas. We also work, though, with politics and with Parliament across parties in a part of what we do, which is really to make the case for nuclear, why it's important, how it fits into other aspects of debates around energy and industry and economic activity, of which all of us. So we undertake briefings for members of Parliament and their staff. We respond to consultations which come government and opposition parties, take part at party political conferences to be able to put together events. And there's an all-party group on nuclear energy, which has members from across different parties and different parts of the country, advocates for nuclear in Parliament, largely because of their constituency or professional interest. I'm saying this in this event today is just to underline that our experience is that it is really important that the case for nuclear isn't just assumed, that it's made and needs to be made, and it's put into the context and relevance in which other policy development is happening. Otherwise, you can get left behind. Important aspect of what those trade organisations can do. So just coming on a little bit to why we're doing nuclear in the UK, our current electricity mix. This is the year figures for calendar year 20, so the most up-to-date figures that we have. They publish those the sort of midpoint of the subsequent year. So these are published in June, but they cover 2019. And you'll see from that two things. Firstly, nuclear of the low carbon sources of generation is the largest over the course of the year. The wind, it fluctuates day to day, but also the year, 9.9% onshore, 9.9% offshore wind current. But the big thing you will see is the amount of gas, 40.6% of gas being burnt for electricity. That's what we need to replace with a combination of the things that are blue and green and yellow in that pie chart. And it demonstrates there is a very long way to be able to get towards a decarbonised power supply. And that means that we're going to need more of all of the other things. So it's not about nuclear versus wind or solar. It's about how you get the best combination that suits the geography and the climate of the country to be able to get that future low carbon mix. So is a policy which has been adopted by the UK Parliament a year and a bit ago, which effectively says that by 2050, and that is the earliest credible date that the climate experts have suggested, to get to net zero emissions as 1990 levels. That means basically, in terms of how we do this, change to behaviour. Committee on Climate Change yesterday in the UK published what they call their carbon budget for the years in the 2030s, which highlights the activities around how much flying people do and behaviour in terms of heating at homes and all sorts of things will have to change. In terms of electricity, the assessment is that in the United Kingdom we will need twice as much electricity capacity that we currently have. That's because decarbonising heat and transport need either electricity or electricity as the feedstock for the fuel that's used. That's hydrogen, for example, or just heating. And because of what we showed you on the previous slide, that means for the amount of low carbon generation that we currently have. A significant expansion of wind, and offshore wind will probably be the largest element, but reminding us that if we're going to have a decarbonised power supply, the variable outlet from offshore wind. Whilst that might be the majority, 57% is their assessment. Firm power, which basically means electricity that isn't impacted by the weather, is going to be required to help to balance the system. And that basically means you can do that in a low carbon way. It's nuclear, or it's retrofitting carbon capture and storage, and that has a significantly higher carbon footprint than nuclear. So there's a lot that needs to be done from nuclear in the future in the United Kingdom if we're going to meet those targets. That's why the Nuclear Industry Association, we produced a roadmap earlier this year called 40 by 50, which is setting out the steps that need to be taken to get to that 40%, which is our current portion of low carbon power, by 2050 in a scenario where the power system is largely decarbonised, and drawing out the fact that by cutting carbon through nuclear, also creating jobs and providing that energy security, which are two very important priorities for government. That's available on the NIA website. People look at it, but this just shows you the scale of what needs to happen in the United Kingdom. You can see our existing fleet, the dark blue at the bottom, is coming towards the end of its lifetime generation. The first of our current fleet will close early part of next year, so early part of 2022, so just over a year's time, and they will progressively come offline during the course of the next 10 years. So if we did not, that red line basically is all the capacity we would have. So we currently have about 8 gigawatts, with under 5. That is a combination of Hinkley, which is under construction, and lifetime extension for site as well. B, which is our station, which is the most recently built one, which was in the early 1990s. And that could go probably to 2050. If we do nothing, we're way short of what's required to get to that net zero with 38% of power from firm power source nuclear. So the mountain that we've got to climb, you can see, is something there's a lot of capacity to deliver, and it will come from large scale reactors, it will come from small reactors, and in the future, towards the end of that period to 2050, probably from what are called advanced modular reactors, particularly the high temperature reactors that can help to produce hydrogen most efficiently. We're going to have a significant hydrogen economy. But the point being, we need all of those technologies to be able to get to deliver the bit that we need to deliver to get to that 2050 target. It's a very target to get to, and something that's going to need a lot of work and a lot of focus from government, from policymakers, industry, and from us. And this is in a UK context, how nuclear contributes to net zero. It is about electricity to the grid, but it's also about providing the basis for hydrogen for transport, synthetic fuels for aviation and maritime, district heating for building industry, agricultural use as well. So there's a whole range of different things that nuclear can contribute to the task of getting to net zero. And a consequence of that, which is really important, is the prosperity and well-being that can create. What we set out on the roadmap, it means an industry of 300,000 people and 33 billion a year into the economy, through construction, manufacturing, science, research, and operational jobs that will last for a very long time. And the other benefits that come from that, with exporting potentially technology, attracting investment in radioisotopes, which are very important in medicine as well, and the wider R&D impact that can be used in other sectors as well. So in the last week, couple of weeks, have published some documents. There's another one due on Monday. So the first thing was a 10-point plan for a green industrial revolution. That's about net zero, very high level, but it's a plan, not a menu. And one of those points, number 3, is nuclear, large and small scale. So nuclear is very firmly now explicitly within the list of things that need to be done to meet net zero, and is being termed as a green industrial revolution. So it includes like hydrogen, offshore wind, electric vehicles, a whole range of different things, but nuclear is part of that, which is very important, because oftentimes in the past, sometimes nuclear would be sort of left out or left on a limb or something a bit separate, but it's a sign that it's a very integral part to how net zero can be achieved in the UK. They've also published the National Infrastructure Strategy, which begins to set out what is required to meet net zero in a bit more detail. And again, on nuclear, highlights the importance of nuclear in economic activity, supply chain development, and the need for nuclear as being alongside other things rather than instead of it. And this is really important because there have been reports that suggested that you don't do very much nuclear, you do a little bit. That's been updated through that infrastructure strategy. On Monday or early next week, we anticipate we will have an energy white paper, which will set a bit more detail out as well. So this is all part of what the UK at the moment, which is as well as having to deal with a pandemic, as well as having to deal with what headlines today around Brexit and all those types of things. Government has also knows that for meeting a 2050 net zero target, a lot has to happen and start to happen now, and that's starting to get some attention and drive from government, and that's really very important for our industry and for the UK more widely. So we're going to do all this nuclear. Where are we going to do it? This just quickly shows you the sites for nuclear new build. Hinkley Point C down on the sort of bottom left is the one that's under construction. On the right-hand side, bottom right-hand side, you Sizewell C, which is the one that EDF want to do next, anticipate doing next. Bradwell B, which is CGN led in a similar part of the country. And then sort of halfway up on the left-hand side, a sort of pink colour, which is Wilver Newydd, which is in North Wales and Anglesey, which is the Horizon project. Was going to be a Japanese technology, maybe another technology, but that's a very good site for development. You will see all of the potential sites for small modular reactors that are in yellow there. The point of putting these in is there are a number of sites which are not suitable for large-scale reactors, will be suitable for smaller reactors, and those are nuclear license sites that are currently potentially available for that, depending on how government takes the siting. But what that really shows you is there's plenty of places we can build this, but it will spread activity across all of the country if we do that. So Hinkley Point C is the first new nuclear power station project being built in the UK for a generation. It's been a long time since Sizewell B was built. So this has been a project which started effectively right at the very end of 2016, so early 2017. So about into the construction period. That's obviously which in the months has been somewhat disrupted by COVID, but not to a huge extent. They have been able to carry on with construction activity during the past few months, albeit with extra restrictions on social distancing, etc. But when it's built, it'll be 2 reactors that produce 3.2 gigawatts of power in the twin reactors, powering currently 7% of UK electricity demand, but that electricity demand will go up as we decarbonise. And there will be 25,000 jobs created during the construction preparation and then in the operation of over the course of that 10-year period. And then in terms of the operational jobs, 60, 70 years or more. £2 billion has been spent on the local supply chain. EDF have worked very to develop local supply chain and utilise local companies as far as they can. And there is a target of 60 odd percent. I think we're on 67% of spend on the project is coming by contracts, is coming to either UK companies or you join, so a significant impact into the economic benefit. And we shouldn't forget the human benefit of this. So far, 700 apprentices have been trained down in that part of the country, which is an area where it does have its pockets excluded, and that's been very important for enabling people who wish to do so to have a job and a career and a livelihood that is close to where they're from, rather than having to away. And those are all benefits that can be replicated to others as new projects get underway. Obviously, a benefit of doing one is that you do the next one, and the ones after that, you can get significant fleet effect benefit. We've seen that with other technology. Offshore wind costs have come down. Same can happen and will happen with nuclear. It's already happening actually in relation to the construction construction of Unit 1 to the construction of Unit 2 at Hinckley. And just about one particular stat that's on there, it's construction for aspects of you around 30% quicker than Unit 1. That's just the benefit of having done it and having the same people then doing the next one. You get quicker and more efficient and as you do them. And the benefit of that fleet effect can happen into Sizewell C if Sizewell C, which is the next project, goes ahead. C would be the same technology use, same sort of footprint on a different site, almost exactly the same. And the difference with Sizewell C that is worth flagging is that as well as the electricity demand, there is a proposal for an energy hub, development of hydrogen and direct air capture and others, which will help to meet the wider net zero agenda. There's a consortium of more than 150 companies and organisations that are in supporting Sizewell. This is a project which we hope and soon and get the go-ahead relatively soon to enable to get the benefits from what's been happening at Hinckley transferred to Sizewell subsequently. As well as the large-scale reactors, there is I want to just mention very quickly, and I'm short of time, small modular reactors, which there's a UK consortium led by Rolls-Royce, and this is relevant in terms of the discussion around supply chain and UK content or national content, local content. This is a consortium of UK companies that are using a Rolls-Royce reactor technology, adapting that to be able to be used in a way which is applicable for a whole range of different sites on the map that I showed you before, and will be mostly factory built and then constructed on site, with the proposition that by having modular construction, you get economies of volume. By the more you do, the more efficient you get, and you can do them effectively with putting together the components that come from factories and are all built to exactly the same standards in typical factory technology approach, with the intention for these small reactors to be utilised in some of those stages and then potentially as an export opportunity as well. This is something which is recognised in the 10-point plan I spoke about and in the infrastructure strategy, and we think will be in the white paper that comes soon. So again, with small modular reactors, their importance for grid electricity I've talked about, but also worth underlining, if we're going to have a significant amount of hydrogen, how you get the hydrogen in a way which means it needs to come from zero carbon sources. So that is effectively large scale offshore wind and nuclear, and so SMR can play a part in delivering that hydrogen and the district heating as well through their utilisation. So they're a flexible technology which can be a significant part of the future UK. Sorry, I've rushed through that towards the end quickly, but that is a summary of where we are. Okay, the policy framework that exists and is developing and evolving, and the technology that we're looking to deploy and to use, and how we're doing that in a way which maximises home content and to grow and develop the supply chain at home. So I hope that's of some interest and use, and very happy to take any questions that anyone may have.
Dziękuję bardzo za tą.
Thank you very much for this presentation. Of course, there is a question, because that is also the deal that we had. And the question is about using local industry, because we all know that for Poland this is an extremely important topic. My question would be, how the Polish government or the Polish authorities or a Polish company that will be the general contractor, the main investor, how should they determine their expectations for cooperation with the local industry? Should it be an element of the contract with the technology supplier? How is this done in the UK? Because of course it's no secret that we care to have as much new jobs created and to make use of our local potential.
Yes, yeah. There's a couple that have been done in the UK and are evolving. The first is, I suppose, a policy instrument that comes from government, which is any large-scale new development approved needs to have a supply chain plan. and that supply chain plan is very heavily focused on where you can utilise UK industry to be able to contribute to that effort. How you do that practically, a couple of things that we've done in the UK. Firstly, going back a few years, the NIA produced a capability report which set out where the capability is in the UK, need for nuclear construction of whatever technology. Secondly, establishing where the gaps are and things that potentially the UK industry that's work sectors may well be able to do. And there is a program which is run through the Nuclear Advanced Manufacturing Research Centre called Fit for Nuclear, which is about encouraging companies who have engineering or manufacturing expertise in particular areas, working in different sectors, for example, in oil and gas, is one which obviously springs to mind, where their capability can be adapted to work in nuclear, and that nuclear isn't as daunting as it perhaps seems, dealing with the different regulatory regimes. And to give you one very, very specific example, there is a company in England, a small engineering company in Lincolnshire. It's part of England, nowhere near any nuclear power stations. And the main thing that they did up until relatively recently, I don't know if you have it in Poland, but there's a breakfast cereal called Weetabix, which is, well, what it sounds like. It's sort of wheat, sort of biscuit thing that you put milk on and people have for breakfast. And they basically manufactured the parts for the supply chain for manufacturing or producing the bisques, the Weetabix bisques, as they came on. And Weetabix is a company that did it all very locally, so it's all in that area. With that support through that Fit for Nuclear program, that company began to manufacture parts that are used within turbines, which are then used in the nuclear industry. So it's not something that's only applicable to large, it's applicable to small companies. I think with the right attitude and imagination, there are many ways you can find the natural ingenuity that many businesses have, with the right support to be able to give them an opportunity to be involved they wouldn't necessarily have thought they were part of into the future. So it's possible, it can be done. There are some things, though, I would just have to say that we can't do in the UK. We can't do big forgings, for example, so they're imported. But you know, we have got at Hinkley 67% by value of that coming into UK companies, and that's a sort of proportion that we would anticipate being for future projects, be those that technology or other technologies, just because of the mix of skills we have, and developing the supply chain, be that small and large companies, can have a massive impact. So there's a lot which industry and government working together can do to maximise the economic benefits, and that's as true in the UK as it could well be in London anywhere else.
Dziękuję bardzo.
Thank you very much for your presentation. I'm very happy to have had you here today with us. I hope that we'll meet many times in the future and with our next seminars. Thank you once again for your attendance, and I would like to invite you to the next presentation. It will be a video presentation. We have two guests from Finland. The first presentation will be a video presentation, and you will be able to listen to a presentation by Juha Mikulainen, who is the development manager at the Finnish company Fennovoima. Then we are going to connect to Katarzyna Zasadny, with whom we will be able to talk directly. So I invite you to watch presentation from Juha. The title is Experience of the company in implementing a Finnish project, Lessons for Poland, a case study. Dzień dobry Państwu, witam z Helsinek, Finlandii.
My name is Juha Miikkulainen, and I work at Fennovoima as development manager since the beginning of the project. Fennovoima is a privately owned nuclear power company. The Finnish majority shareholders include major corporations operating in Finland. The plant supplier Rosatom owns 1/3 of Fennovoima. Hanhikivi 1 nuclear power plant is being constructed in northern Finland, seacoast of the Gulf of Bothnia, in little town Pyhäjoki, with around 3,000 inhabitants. Construction license in compliance with the Nuclear Energy Act from the government, is required to start the construction of the nuclear power plant itself. The design documentation must be completed and the Radiation and Nuclear Safety Authority must approve the plans. Fennovoima expects to receive the construction license by the end of 2021 and nuclear power plant to be completed in 2028. Since Hanhikivi site kick-off summer 2014, dozens of kilometers of roads, municipal engineering and a variety of buildings have appeared in the Hanhikivi Peninsula. Before the construction of the actual NPP, infrastructure and auxiliary buildings worth some 500 million euros will be built in the site area. Fennovoima owns more than 550 hectares of land and water areas. The fenced plant area has been raised to 4.6 meters above the sea level, protecting from the Baltic Sea water peak levels. More than 1 million cubic meters of crushed stone and blasted rock has been used for this. The power plant site excavation is executed and the pit size is about 12 hectares. The excavation work will continue and the pit will be about 15 meters deep inside the tough Finnish bedrock. Hanhikivi Peninsula can be divided roughly into two main areas: fenced plant area and auxiliary industrial area outside the fences. The plant area will contain reactor, turbine and auxiliary buildings. The industrial area next to the fenced plant area contains training building, accommodation village, warehouses and contractors area for different kinds of industrial and entrepreneurs functions. The first project to be able to open the greenfield site was to build a new 4-kilometer long road, which was completed in 2015. The price of the road is approximately 1 million per kilometer. The first permanent building completed in the area was the training building in 2017. The budget was around 2 million euros. The training building is used to arrange site access training and create access permits for new employees at the construction site. It also houses office and service point for the authorities. The site main gate building was completed in 2017. The budget was 3 million euros. Once the project is complete, all access to the plant will be through the main gate. The main administration building and plant office will be built in a central location right next to the plant. The total size of the office is 18,000 square meters and the value of the contract is approximately 30 million euros. The fire station will also be built at the plant area. The main supplier Raos project is responsible for designing and constructing the plant according to the turnkey EPC contract. The main contractor, Russian company Titan II, as a sub-supplier of the main supplier, is responsible for construction of the plant. The accommodation village at the vicinity of the site will offer quality accommodation for 1,000 workers. The building cost of the village is about 20 million euros. There will be other types of accommodation commercially available also in the surrounding towns and areas for the rest of thousands of workers. At the site area, there are auxiliary functions such as canteen for 600, site offices for 400, and sanitary premises for 2,600 people. The reinforcement plant is currently being built with an area of 15,000 square meters. In addition, sorted waste station, concrete patching plants, and office premises have been built. Extensive work has been performed in the sea area. Dredging and excavation of the cooling water outlet channel is ongoing. South of the peninsula, there is the seaport area. The port structures have been dredged and breakwaters have been constructed. The harbour will serve the power plant during the construction stage and annual outages. The largest components can be brought to the site by the sea. More than 80 authority permits have already been applied for the infra work before the construction of the plant. such as municipal building permits, environmental permits, and water resources management permit. So far, more than 600 companies have participated in the work, most of them Finnish and around half of them inside the radius of 100 kilometers. Access permits have been granted to more than 3,000 employees, 80% of them from Finland. At the moment, the infrastructure and preparatory works ongoing, the site daily headcount is approximately 250 people. During the busiest construction period in 2024 to 2026, more than 4,000 people will be simultaneously working at the site. Hanhikivi 1 project has given a major economic boost to northern Finland. According to recent studies, one job at the construction site creates around 5 jobs outside the construction site. The completed power plant will employ some 500 people plus a large number of seasonal employees. The municipality of Pyhäjoki has estimated that once complete, the power plant will bring up to 1,000 new residents to the area. The local commuting area with radius of around 50 kilometers includes 4 towns and smaller villages with 80,000 inhabitants. The main business areas are metal production and agriculture and tourism. The regional infrastructures are considered to be able to host Hanhikivi 10-year mega project with peak volume of 4,000 temporary workers and altogether over 20,000 accredited workers over the project span. The new power plant is expected to bring 1,000 new residents to the area, majority of them highly educated experts for plant operations for 60 to 80 years. The municipality services in Finland are generally excellent, even in the smallest towns. The municipalities have been actively developing their services in close cooperation with Fennovoima since the very beginning. Also, the local authorities have been following closely the project and participating in the development actions. Open dialogue with all the stakeholders is the key issue. Municipalities, local and regional decision makers, regional authorities, leisure associations, business sector, media, and even the church. Commercial sector operators and companies will establish also a strong service network around the site. Restaurants, accommodation, various industrial services, etc. Fennovoima, as the owner of the Hanhikivi project, has a communications department providing strong local, national and international presence. Helsinki head office and Pyhäjoki local communications office with 5 to 10 professionals have actively promoted the project since the beginning of the project in 2007. The main sectors being communications, networking, lobbying, PR, social media, events, publishing and sponsoring. Supporting the curiosity of the local people and especially local politicians and the civil servants requires 3 to 5 professional communications experts with strong social skills and technical background, or assistance of the technical staff right on the street level discussions on site region and different events and occasions. Fennovoima managed to recruit talented, locally well-known people to run the local communications office. The local office in the municipality center is open daily basis, offering warm coffee and lots of information to locals. Fennovoima created regular meeting procedures with all the key regional stakeholders and invited representatives for discussions and learning from the experience and status reporting. General public hearings and mini-seminars have been organized. Fennovoima has organized open site tours annually for thousands of interested people and their families. The average annual budget of communications activities is on the level of over 1 million euros, up to 3 million euros without salary costs. The works on infrastructure and auxiliary structures will continue at the site this year and next year. Construction of the plant will start when the construction license has been granted by the government, which is expected to happen in 2021. Once complete, Hanhikivi 1 will produce emission-free Finnish electricity at a stable price for at least 60 years. Thank you for your attention.
To była prezentacja.
This was a presentation by Juha Mikulainen. Thank you very much for this presentation. In a moment, we are going to connect to Katarzyna Zasadni, who also represents the Finnish company. But before that, I would still like to invite all our guests, all our speakers. You can still ask questions to our speakers. And now let's connect to Katarzyna Zasadni, a senior expert at Fennovoima. Katarzyna, I hope that you can hear us and I hope that you can see us. Good morning. I will be speaking in English.
I have worked in Fennovoima for the last 6 years in the nuclear island department, that's reactor and those 12 buildings around it that support it. Here you can see the schedule of Hanhikivi. We are now at the construction license phase. The construction of the nuclear power plant is composed of 4 key milestones, which are accompanied by 4 key activities. Once we get all the surveys, we can have the decision in principle from the Parliament, and then we can choose the technology and sign the contract. Most of the countries don't have their own technology, so they have to import this technology together with the engineering experienced staff. In Finland, there are 2 nuclear power plants currently, and still 1/3 of Fennovoima staff is from abroad. There are more than 90 process systems supporting the reactor. So in 2019, Department of Nuclear Island consisted of 24 engineers from 10 different nationalities. Many of them came to Finland just for the project, like me. Staff experienced in expertise suitable to the project phase is also critical. But we all know that it's not so easy to acquire and keep the experienced staff. So the company interest in well-being of the employees is very important. Also, majority of Fennovoima staff of Finnish descent has the nuclear background. So for Poland, it is important to start the campaign of interests from young people to start this education profile. You have still time. Nuclear facility safety is ensured by the defense in-depth principles. And to make sure that defense in-depth principles are recognized on a safety level, we need to allocate safety functions. Starting from the top, safety class 1 consists of the barriers that are needed or their rupture would cause the failure that would be a very dangerous, serious event. This is a passive function. Safety class 2 composes of system structures and components required to reach and maintain control state, but also those which are required to reach the safe state during severe accidents. Containment isolation is a good example. Safety class 3, those are systems that are needed to reach the safe state, meaning that the reactor has been shut down, decay heat has been secured, and reactor is no longer pressurized. Then we have EYT STUK class. This is only functional class. It contains the systems which are important for safety functions. Those may be fire protection systems or also systems which are required to reach the control state and safe state after severe accidents. And finally, the last one is non-safety function. Majority of turbine island and balance of plant belongs to this class. Once we have the safety classification established, we need to also classify the components from the seismic resistance. Taking into consideration the design basis earthquake, S1, S2A must withstand this earthquake. S1 must stay operational. After that, we also need to qualify all the equipment working parameters during normal operation and accidents. Temperature, pressure, radiation, vibration. Naturally, safety classified systems has much more severe conditions of work. So safety classification defines the requirements and qualification procedure for nuclear systems, equipment and components. All those here pointed points have higher demands for the safety classification. For example, manufacture of safety class 1 and 2 components and equipment must have a nuclear experience. So to conclude, the classification is pretty straightforward, but there are some cases when it leaves some flexibility. Naturally, the safety classification is more reliable, but then it means that it decreases the available manufacturers. Actually, HVAC equipment is a very good example of this case, because the entire nuclear island is composed of all possible safety classified ventilation, except of course safety class 1. Poland has many manufacturers with a good quality and best available technology, but they have never performed their equipment to qualify it for the nuclear business. So for now, they might not be even capable to deliver anything for the safety class 2. And finally, the EPC contract. Turnkey delivery is quite typical part of the power sector. EPC contracts cover the entire life cycle of the plant, including the slightest details of design, construction, scope of equipment, spare parts, manufacturing, everything. So it's natural that the owner prefers to handle the scope to the supplier. But the supplier may not be from Europe, may not be from European Union. It may mean completely different design, construction, and manufacturing practices. European Union has a set of common standards, Eurocodes, but each country has its separate legislations and practices for authorities' approval. I have pointed to several ones which I think are critical in Poland. And it may mean that the external supplier will simply not be capable to meet those requirements without a schedule delay risk. And Poland has quite demanding set of legislations and the practice for the authority approval. For example, pressure equipment approval by the UDT, which is the 10 point. So it would have to be thought through carefully what scope of the contract and who should be responsible for that and how to handle this process. Thank you.
Dziękuję bardzo, pani Katarzyna.
Thank you very much, Katarzyna.
Tak, mamy pytanie. Mamy oczywiście pytanie. Pani
Yes, of course, Katarzyna, we do have a question for you exactly about the last topic that you touched upon, because when preparing for today's conference, for today's seminar, I found a mention in the Polish media about the execution of your project. Let me just quote a comment from one of your company's representatives, and then I will move over to my question. Now, I quote: when executing this power plant, taking into account the Finnish requirements and legislation for design work, it took the technology provider more time to account for these than was initially expected, because delivering documents during the first 2 years was slower than we anticipated. That's the end of the quote, and now, Katarzyna, could you please suggest what should we do in order to avoid such problems in our project? We know that we're just starting the nuclear project. Can something be done efficiently or perfectly to determine requirements for the technology supplier and then enforce them efficiently? It's difficult to say whether this might be done perfectly, because every project, everyone learns from scratch. You can't anticipate everything, but planning in such a situation is the key element. First of all, recognizing procedures on your part and any cultural differences that might entail all the potential situations that might appear in your project. For me, getting involved of a third party, I don't even know how to say it in Polish, perhaps not an organization, but at least on the part of the owner, getting the appropriate people involved, that people that have experience, domestic experience, when working on the individual disciplines. So just create groups that could anticipate a problem even before it appears, to find a solution and establish how this works in Poland. There's a lot of such disciplines. For example, the fire protection discipline, the electrical discipline. Every discipline has its own specific circumstances. These are usually, in Poland, these are usually very stringent. I have some experience with that, so I do know. So can we just say that our regulations are so very strict? Because you mentioned the technical supervision authority, now fire protection. So I understand this would indicate that it would be a difficult task for us to execute this project, and we all hope that we can still make it on time. Everything can be done if the team is prepared, if people are prepared, so everyone knows what their task is, everyone is knowledgeable about the contract, what do we expect, and what the supplier could give us. And in Poland, it's not so very demanding, but it's actually quite good. It's actually something that I would say that I sometimes miss, because, for example, for the fire protection discipline, we have a fire protection engineer who comes, signs the design, he inspects this in detail. There are procedures that need to be fulfilled. In Finland, there is no one pays for such a person. The fire authority, of course, inspects everything, but it's not so. It's also not written. It's not included in their legislation the way we have it included. So that's actually a good point. I'm very happy to hear that. That, on the other hand, safety is paramount. So I think that these arrangements will be key. Katarzyna, thank you very much for attending our seminar. I invite you wholeheartedly to our next seminar. If there are any questions from our audience, from our listeners, you can, of course, we will forward these to you. Thank you very much for attending today. And we're now moving over to our next guest. Thank you very much for your patience.
Przechodzimy już i łączymy się z kolejnym naszym
Now we would go on and join with our next guest, Mr. Viktor Kum, who represents Korean hydro and nuclear power. And the title of the presentation is a case study example of successful localization in Korea, technological transfer. And now we are trying to connect with Mr. Victor. Welcome.
Hello.
Hello, my name is Victor Gun from Korea Hydro Nuclear Power Company, and I'm pleased to give this presentation. And today, let me talk about Korea's experience, hoping that it can assist Poland in achieving successful localization. The contents of my presentation are as follows. Why localization? MPP construction not only contributes to the energy sector, but also to the national economy by developing cutting-edge technology, acquiring investments, and creating new jobs. As one of the most important factors in MPP construction, localization benefits the government, industry, and contractors. Through the introduction of new technology, the industry can develop technology and make profits. Based on close cooperation with the importing country and accumulated technology, it is even possible to advance into the global market. By utilizing local resources, the industry is developed and jobs are created. The nation's GDP is increased, which not only improves public acceptance, but helps raise public support. For the contractor, the project cost can be reduced by using local raw materials, equipment, and manpower. By cooperating with the local companies that are knowledgeable in the local regulation and laws, it is possible to minimize risk for licensing. Furthermore, by shortening the delivery and period of major raw materials and equipment, the risk in project schedule and cost can be minimized. And also, by expanding localization through a nuclear new build project, Poland also expects to create more jobs, upgrading technology and quality, and subsequently achieve technology self-reliance and participate in global supply chain. For this, I hope that Korea's experience can assist Poland in realizing its goals. Okay, now I talk about Korea's experience in localization. Based on long-term power supply plan in 1967, the Korean government confirmed plans to construct 2 units of 500 megawatt reactors by 1976. Taking into consideration Korea's level of technology at the time, we used the EPC turnkey method for construction under the condition that suppliers secured foreign loans. Korea's first MPP, Gori Unit 1, began construction in December 1971 and commercial operation in April 1978. When first introducing MPP, Korea especially complete reactor type, while Poland has decided to introduce the PWR. Back then, there were 3 reactor types in operation in the Western Hemisphere: the AGR, Advanced Gas-Cooled Reactor, BWR, Boiling Water Reactor, and PWR, Pressurized Water Reactor. Each of these has its strengths and weaknesses, but they were all similar in terms of overall performance. When making the decision, the BWR was the first to be eliminated because the nuclear fuel made direct contact with the coolant. With the PWR and AGR remaining, the opinions of the researchers involved in the decision-making were divided, and positions were completely conflicting. As research with expert knowledge on both AGR and PWR was selected to travel the US and UK and conduct field surveys. As a result, a report on the superiority of the PWR was submitted to the Korean government, which made a final call in favor of the PWR. Not long after the decision to construct the Gori Unit 1 as PWR, it was discovered that the AGR had critical issues. The UK government banned the export of the AGR, which eventually disappeared from the global nuclear market altogether. In 1971, the early stages of MPP construction, Korea per capita income was just $290 US, and the amount spent on Gori Unit 1 was $130 million US, is 4 times the state budget. While the nuclear plants constructed in Japan around the same time were all BWRs, Korea, which was a much poorer country, chose the more expensive PWR. This was an extravagance that basically took a gamble on the nation's future, which in retrospect was the optimal choice in terms of safety. While there are many factors that contribute to successful localization, human resource development for the industrial infrastructure should be implemented in advance as a top priority, and legal system related to nuclear power must be established on the same basis. For this purpose, the role between the utilities and government agency should be clearly defined in advance. The MPP introduction plan should be established with sufficient lead time. The first MPP would be constructed with a turnkey contract, and it is important to select an overseas company with both experience and technology. It is also important to establish a risk minimization plan to address all potential problems. Even if the turnkey approach is adopted for introduction of the first MPP, the scope of the utility participation should be considered in regards to localization of MPP construction and operation. When negotiating the contract, the fixed portion or reimbursable cost for training and localization must be harmonized through an in-depth review of the reimbursable portion. The record and document management system must be established during the construction of the first unit. In particular, the document management system, which systematically compiles the experience, must be established from the beginning. Korea, which has no nuclear power plant construction in the early 1970s, faced many challenges through the turnkey project, such as delayed delivery of equipment, high price governed by a single supplier, sluggish accumulation of domestic technology, delayed development of nuclear infrastructure, etc. As a result, Korea decided in 1975 to implement a non-key approach to be led by project owner for the construction of Gori 3 and 4. KEPCO, now KHNP, took charge of the project management and contracted experienced companies for architect engineering, nuclear steam supply system and turbine generator supply, fuel supply, construction, and so on. We increased the participation of domestic companies as subcontractors and cooperate with the foreign main contractor in each area of construction for efficient project management to accumulate technology by improving quality assurance and localization. Decision-making was strongly supported by the government policy for localization of nuclear power plants. KEPCO ENC was in charge of basic design, and domestic companies such as Doosan Heavy Industries, Hyoseong, etc. were involved in equipment supply. When Korea first announced the Gori 3 and 4 project as owner-led non-turnkey, it gained negative response from the world nuclear industry. There were even comments that the project would not be successful, undermining KHNP's capabilities. In order to minimize the risk related to the first non-turnkey project, we took on project management for the first time and selected Bacteria as architect engineer for Korea. KHNP faced many challenges, especially with construction schedule. The cause of delay included the required design upgraded following the nuclear accident at TMI and delay in the delivery of equipment from overseas due to stagnation of U.S. nuclear industry. The schedule was further impacted due to the delay in delivery of the localization equipment from the suppliers because of their lack of design capabilities and inadequate quality control. The delays were worsened due to the lack of construction experience and the first use of non-turnkey approach. In order to overcome those risks and challenges, it was necessary to expedite the process. KHNP stationed staff in the manufacturing plant and made sure that inspection and corrective measures were taken at the production factory. In order to procure urgently needed materials, KHNP operated a purchasing team at the construction site. The schedule was completely controlled separately, so in order to integrate the control of the schedule, we created an integrated control office. As a result, we were able to successfully complete the HFT within 3 months without critical delay. 3 months after the field loading, the grid connection test of a generator was performed and succeeded in dispatching 700 kilowatt hour with a maximum 60 megawatt power during the first try of electricity transmission. The level of equipment localization was less than 10% for the first unit. During the construction of Gori 3 and 4, it was raised to 30%. The same approach was applied to the next plant, Hanbit 1 and 2. As a result, 44% of the design sector and 35% of the equipment manufacturing sector was successfully localized. For the Hanul 1 and 2 project, great efforts were made not only for localization, but also for technological self-reliance. The rate of localization for design was increased to 46% and equipment manufacturing to 40%. In the event the construction of multiple nuclear power plant is planned after the introduction of first plant, the project management capabilities of the utility can determine whether the project is successful regardless of contract type. At the time of contract negotiations, priority should be placed on developing the project management capabilities of the utilities, as well as establishing a well-planned system for overseas training in each field. When government establishes a localization policy, it is recommended to designate companies for each area, such as architect engineering, manufacturing, major components, and construction to provide definite assignments and roles. The power utility has to secure professional experts from each field in parallel with launch of government MPP introduction team, because the utility must be main body in charge of the MPP construction. If securing professional independently proves to be difficult, hiring a specialized and experienced engineering company is a viable alternative. Technology self-reliance requires capabilities for operation, construction project management, architect engineering, structure construction, localization of auxiliary equipment, turbine generator, major reactor components, and finally the NSSS system design. Once these processes have been completed, localization and technology self-reliance can be achieved. While construction of GORI-1 was based on foreign technology through the turnkey method, self-reliance of operation technology was achieved through training. During the construction of GORI-1, GORI-3 and 4, Korea was able to greatly enhance its project management skills, as well as gain significant achievements by dispatching engineers to overseas companies for joining design. To increase localization, equipment specifications were customized to strengthen the basis for cooperation with domestic industry, and we were able to localize auxiliary equipment and major parts of the reactor. However, there still remained dependent technology. The final stage of technology self-reliance and the key to project was the localization of the nuclear steam supply system technology and major reactor components. Only after achieving this could we complete the self-reliance of nuclear power plant design and construction. While the Korean government and utility were reviewing plans for Hanbi 3 and 4 construction, the technology self-reliance program was established in 1984. The course of action was to complete the Korean standard MPP and replicate at least 6 more units after accumulating technology from Hanbi 3 and 4 with the goal of developing reactor design and manufacturing technology as well as economic improvement. For technology self-reliance, KHNP launched a nuclear new build TF to be in charge of technology transfer and select the construction company for Hanbi 3 and 4. Without any assistance, we prepared the invitation to bid by ourselves, which was mocked by foreign companies. Nevertheless, the ITB was sent to potential bidders in November 1985, and the companies that mocked us were shocked. There was no room for loopholes or exceptions to areas such as payment, warranties, liabilities for securities, etc., and the compensation for design service were based on fixed cost additional method to supplement previous weaknesses. There are 3 main hurdles for technology self-reliance: issuing the ITB, tender evaluation, and technology transfer. The ITB was successfully overcome, but the following tender evaluation was a rough journey due to external pressure despite our determination and capabilities. In order to ensure fair evaluation, the nuclear new build TF decided on evaluate criteria for each contract. The evaluation lasted 6 months, and while it seemed to proceed smoothly from the outside, there are many factors that attempt to influence the decision-making. Nevertheless, KHNP's CEO entrusted the entire evaluation process to the TF and directed that the decision was made fairly. The result was based 100% on the evaluation of the TF members. The suppliers for NSSS system was awarded ABBCE, the turbine generator system to GE, and architect engineering to Sargent and Lundy. When the announcement was made in September 1986, the world nuclear industry was taken by surprise. The companies that won the award and those that were not selected were all shocked by the unexpected results. Korea had one main criteria: who would transfer the most technology under the most optimal conditions. Those that tried to use political influence or lobbyists were all eliminated, and it was the first time in the history of the nuclear industry that the decision was made entirely by the working level. This was a result brought about by CEO's determination to shield the decision-making process against external influences. The announcement caused an uproar among those who lost the award, claiming that the evaluation was unjust and insisting a rebid. However, Korea would not let this defer its plan. There still remained the last hurdle of negotiation, technology transfer. The contract negotiation process was intense and lasted about 6 months. Due to the detailed and thorough review of each clause, the complex contract were carried out for 10 years without any conflict among the parties. In accordance with technology transfer agreement, documents were transferred and Korea's design engineers were dispatched to each supplier to participate in joint design. Through technical training, we were able to secure capabilities in core design, supply and manufacturing of major equipment, architect engineering, and BOP design. Finally, with the participation of Korean companies as main contractor of each area and foreign companies providing technical support as subcontractor, the first Korean standard nuclear power plant, the OPR 1000, was developed and constructed. As MPP construction continues, the need for design standardization and technological self-reliance increased. For 1995, the goal of 95% localization was set by KHNP at the preliminary stage of Hanbit 3 and 4 in 1984. Once localization is increased and technology has been accumulated based on the experience from the proceeding unit, the technology self-reliance policy should be established and technology transfer agreements concluded for each area, such as primary and architect engineering, major equipment, fuel, etc. It is the only with the continuous support of government policy for MPP construction that technology transfer agreements can be relevant. Beyond the ownership of technical document, plans for technology independence must be made to develop independent technologies through active R&D. Additionally, the utility must strive to develop advanced technology through continuous education and training. After the TMI and Chernobyl accidents, there was need for the development of next-generation reactor with enhanced accident response features and reinforced the safety as well as a new large-scale reactor for exports. In the early 1990s, the Korean government established a nuclear R&D plan, and in 1992, the Korean next-generation reactor development project was selected as a leading national project. A government-led committee of industry, academic research experts was created, selecting the improved LWR with passive safety features for the next generation reactor. The basic design requirements and design concept was confirmed by applying development trends of new overseas reactors. The R&D lasted about 10 years and acquired standard design approval from the Korean Regulatory Authority in 2002. And the APR 1400 was finally born. Based on our experience from successful projects at home and abroad, we are continuously making efforts to supply MPPs that meet the requirements of US and Europe. Okay. Summary. Building a long-term plan for localization is mandatory in accordance with the long-term power development plan. A rapid approach to localization without an advanced plan will most likely result in failure. A step-by-step approach that takes into consideration the industrial situation of the nation is recommended. For areas the lack of sufficient technology, the best solution is to introduce the required technology from a foreign company such as KHNP that possesses specific expertise and to form a technical partnership with them. With the joint efforts of the government, utility, and manufacturer for localization, I have no doubt that the future of Poland's nuclear power industry will be bright. Dziękuję bardzo.
Dziękujemy bardzo za tą prezentację.
Thank you very much for that presentation. I'm very pleased that you are with us. And I would like to ask you one or two questions, even though we have a bit of a delay. My question is as follows. Since Poland has a well-developed industry producing for the energy sector, the power sector, I have the following question. When building the first reactor, should we aspire to transfer nuclear technologies, or should we take over competencies calmly and start such a transfer at the next reactors, with the next reactors?
For the first reactor, actually, when we introduced the first reactor, we actually thought it's easy like building the conventional power plant. For Poland, actually, the industry is really developed, and there are a lot of the conventional power plants. But for the primary side, the reactor, actually the primary side, there are a lot of the technology. So for the first reactor, I recommend actually as a turnkey and the having experience on building. And for the second reactor, the cooperation in the reactor. For the second reactor, you actually get the technology, the transfer of the agreement with the contractor. Then you can actually take the technology as much as possible based on your former experience.
Dziękuję bardzo za udział w...
Thank you very much for participating in our seminar. We're very pleased that we were able to connect with you and to hear your presentation. Thank you also for answering our questions. And now, ladies and gentlemen, I would also like to add that there's a possibility to ask our speakers questions. We will be connecting with our next guest and speaker, and it's Mr. Laurent Olivier Coudeir, who represents EDF France. And the title of the presentation are Risks Associated to Nuclear Projects, seen from technology providers, EPC supply based on French experiences. Thank you very much.
Dzień dobry. Thank you, Agnieszka, for the introductions. I'm glad to have the opportunity to speak today. I would like first to thank Mr. Pilch from IGEOS and especially Mr. Sidlo from Ministry of Climate and Environment for giving EDF the opportunity to support the Polish nuclear energy development. The nuclear project is exposed to many sources of risk, which might be characterized into 4 categories: safety-related risk, operations, commercial financials, as well as strategy. My presentation today will focus on risk management associated to supply chain, as supply chain is one of the key stakeholders of such an ambitious program. My objective today is to share with you the lessons learned for Poland concerning the local industrial involvement, how to maximize it, how to secure it. I have been involved myself for more than 10 years in supply chain activities, in localization program, in UK, in Finland, in China, for the construction of EPR reactors. This includes cooperations with Polish company, because Polish company are already involved in the constructions of EPR reactors. So I am glad to know that some of the company are attending today. A nuclear project is a great opportunity for the industrialization of the country and job creations. As you can see here on the slide, it's about 6,000 people that will be engaged at peak during the construction phase. In addition, about 5,000 people will have to be mobilized for the manufacturing of equipment. So there is a huge need of resources for a period of about 10 years for the construction of 2 units. It's a great opportunity to create jobs, and it's a challenge also to ensure that we have enough resources to be able to manage these activities. In addition, this is a long-term investment. As you can see on the yellow part, it's about 7 to 1,000 people that will be engaged in operations and maintenance activities. So there is a need to have suppliers to support activities on the long term. Lifetime of such project is about 60 years. This is why there is a first risk of resources that need to be anticipated. The mitigation is key by anticipating recruitment within the supply chain, as well as by the next operators. And there is also a risk in terms of competencies. A lot of different competencies are needed. That's why it is important to anticipate trainings and development of competencies. Such a program is creating the job for the next generations. You in Poland are now creating jobs for children that are currently 10, 14 years old. This is why, in order to reduce the risk related to competencies, it is important already from now to develop education program in order to have the new generation familiar to nuclear specific competencies, especially related to safety culture. The supply chain is a key stakeholder for the construction of a nuclear power plant with a nuclear island, conventional island, as well as a balance of plant. There is a need to embark different competencies and a lot of companies. We, as vendor, need to have a strong supply chain to support the construction with us in engineering field, manufacturing of equipment, installation and civil work, as well as marine works or site activities. A lot of activities are nuclear safety classified, especially in the nuclear island, but you have also a lot of activities that are similar to what conventional or oil and gas industry have. So there is opportunities for different companies to be embarked in the program. Because conventional plant is a sector where we know that there are already a good experience and competencies in Poland. In terms of risk, major risk related to the supply chain for a project, this is risk related to quality, time schedule and cost. Definitely, quality is a key asset. There will be no compromise with quality on a nuclear project. And if there is any issue on the quality, this will impact definitely the program in terms of time schedule and on cost. this is not only the project, but also the supplier that will be impacted. So for company, especially newcomers in the nuclear industry, it is key to understand that quality requirements are a priority, and it is important to work in full transparency and to build a trust relationship. This will help the vendor, the suppliers to be more efficient, to avoid also any risk on the quality, and to optimize the cost. This is the major risk that we have on such a program, and this is quality issue. This is why it is important to take into considerations the quality requirement on such a program. That's why a graded approach is a good approach in order to mitigate the risk related to quality. It has been explained before by Pekka. It will be also developed in the afternoon by Bruno Marquis. For all activities related to the nuclear island, especially for the manufacturing of components, we have some quality requirements and the application of different code and standards. This code and standard will help the suppliers to have a good understanding about the requirements, and it provides a good guideline how to manufacture equipment, how to manage documentation and validation of the documentation. For all nuclear safety components, there is the need to ensure a full traceability of the component, and the safety grade that we apply is directly linked to the impact of the performance of the power plant as well on the safety. That's why this graded approach will allow us to limit the risk for the suppliers as well as for the project. There is the opportunity already to anticipate this requirement by having a good understanding on the code and standard as well on the ISO 9443. This new ISO that is complementary to the ISO 9001 provide a good explanation, a good process. It's specific to nuclear, and it's a good way for new suppliers to understand the requirement. As there will be no compromise on quality, it is important for the supplier to have an understanding about the different grade in terms of safety. For the safety grade component, the supplier and in fact the factory itself will have to be qualified as well as the equipment. That's why in terms of localizations or introduction of new suppliers, a progressive approach is a good way to ensure that we will have local company and new suppliers involved in a project. It is often a good approach to start for newcomers with non-safety qualified equipment. As we have explained, a lot of the non-safety classified activities are similar to what exists in power plants or in oil and gas. That's why these activities are already familiar for the company that have experience in other industry, and it's a good way to limit the risk for these companies that are entering in a new market. So it is a good opportunity to start with for newcomers in the nuclear, for non-safety, and you have in addition the opportunity, thanks to a long time frame, in order to launch qualification of the factory, qualifications of the equipment. Because going to safety classified equipment is a long journey in terms of qualifications, in terms of investment. A company that wants to reach safety classified equipment will need to invest in a workshop, in classifications. This is something that is possible for the program in Poland, as we can take benefit from a fleet effect. Having a size of 6 reactors, as we have in Poland, will allow the local companies to be engaged and to launch activities, qualification process, investment that are required in order to be able to also provide part of the safety classified equipment. By the way, some companies were already able to provide for EPR projects some classified components or strategic component like pool liner, for example, or liner for some projects. So there are already Polish companies that have experience, and we are definitely confident that in the frame of the Polish project, there will be a lot of opportunities for the local companies. And involving local companies, for us, is also a good way to reduce the risk of resources, because there is a clear need to embark a lot of companies on resources, and local companies will help also the project to perform expected number of recruitment. To secure from a vendor perspective and to limit the risk, to secure from supplier perspective, also it is important for new suppliers to apply a methodology that will secure quality requirements and good understanding about expectations of a nuclear project. By EDF, we have developed a strong methodology that we applied in China, in Finland, in UK. You know that in UK it has been mentioned earlier. We have been able to achieve more than 65% of localizations on the construction activities for 2 units. So we have applied a methodology where we have at early stage engaged with local companies and with any new suppliers. This 4 steps methodology, it is the one that we described here, and the objective of this approach is to engage discussions with new companies in order to have a good understanding about their capabilities, about the potential of evolutions to go to standard or to safety classified equipment. And this process involves purchasing, representative from our company, quality, and engineering team. We will have a close cooperations, a collaborative approach with a new company that will help the suppliers to have a better understanding about the expectations. Based on assessment visit in the factory, on, as you can see on the step 2, as well on the step 3 with pre-qualification by sharing technical specifications, we will have the opportunity to assess the capacities of the company and together to develop a supplier development program that is based on exchange of technical information, assessment of technical offers, and as well on training courses and workshops. We have implemented some RCC Academy in some countries, in UK, in India. This is what we are doing now. So we have an experience to involve and to improve the understanding and the quality of the suppliers to be ready when the project starts. This process is anticipated, is engaged at early stage. It has been already engaged with some of the Polish companies that we have identified in the last years, and we will continue to engage it. The objective is really to go to pre-qualification and to qualification of the company so that newcomers will have a great opportunity to be ready when the project will be engaged. During this assessment, we will focus on 8 major topics that you can see on the right of the screen. We are looking after manufacturing capacities, management of the purchasing organizations, project competencies, and we will develop together the improvement actions that are needed to be implemented. Another way to limit the risk, we just spoke to how to limit the risk by introducing in a project new companies. It's also to take benefit from already the existing experience. So duplications of a project is key to be successful and to limit the risk. With the EPR constructions, we have been faced already in the past to the first of a kind project, so in Flamanville, and we are now pleased to have this project under final commissionings. Thanks to the experience by EDF that we have now in Europe, in France with our first of a kind Flamanville, but also in the project under construction in UK currently, we have been able to develop lessons learned and to take benefit from this experience that we had by building also a European nuclear supply chain. So we take now benefit from this for the next project. It's also a way to secure the approach, and having already a detailed design that is ready for the next project will help the new countries or the supply chain to start and to limit the risk, to start in good condition and to limit risk related to constructions. So it is key to take benefit from the duplications of the project that we have and apply the lessons learned to improve continuously. That this is what has been done, for example, in China with our project Taishan 1 and 2 that are in full operations now for 2 to 1 year. How to limit the risk for the project? We spoke about that, but how also to limit the risk from a supplier perspective. For new companies, one of the opportunity is also to develop partnership between newcomers and experienced suppliers in the nuclear and especially to the experienced in the specific technology is a key asset to accelerate the localizations. By sharing resources, sharing investment, sharing the strengths of each of the company, sharing the experience. A local company, for example, will definitely have a strong asset by knowing the domestic practices in terms of local construction, in terms of employment rules, country legislation in the country. So there is a key asset by the local company, and there is a key asset by experienced company that are already been engaged, that have a part of the design that is ready. So developing partnership for us between EPR experienced company and the new company is a way to have a mutual gain, and for the supplier, for the local company to accelerate also the opportunity of delivery or being engaged in safety classified activities in constructions. And when I speak about experienced supplier, I speak also about Polish company, because then we have more than 25 Polish company, for example, that has been already engaged in the construction of EPRs in Europe. So taking benefit from their experience, and Mr. Sidlow explained this morning that during the organization of some seminar, some Polish company have the opportunity of testimony. It's a good way also to embark further company and to limit the risk. So definitely this is an approach that we support, developing cooperations. This for the benefit of the project, but also long term for the benefit of the local or newcomer company, because thanks to such a partnership, it's also a good way to have access to further market. What are the lessons learned that we want to share with you today? These lessons learned are based on the different localization program that we have successfully implemented in different countries. This is also the lessons learned that we have from experience, so the feedback from a company engaged in our EPR project. This is also the lessons learned that we have from the assessment that we have performed by new companies. You can see here the 8 major topics. I will not go through all of these topics, but definitely safety culture implementation is key. You have to have in your teams dedicated organizations to support the safety culture implementations. It is key that each of your workers has a good understanding about the implications, about the impact of his work on the quality and on the project itself. This is key that all people in the company have this culture, and because safety is a priority. Sub-supply chain management is also very important. This is not because the company is a subcontractor, will be a tier 2 or a tier 3 company, that they will not have to apply the same quality requirement that we need to have on the project. So definitely, when you are a tier 1 company, you have also to cascade all technical quality requirement to your supply chain. And you have to manage and to monitor definitely your subcontractors. Documentation management is also very important. As you have seen, it's a long-term project involving a lot of companies, so that there are interfaces. At a certain stage, there might be changes in the specification, so you have to be able to have a complete traceability of the documentation, of the change, validation of each of the document. You have definitely to ensure that you have the last validated sketch before manufacturing, so it is key to implement a strong documentation management. You know, we often say that there is when you are manufacturing a vessel, tanks, there is in fact so much paper to provide than steel. So it is really key for you to have the opportunity, the capacity to manage documentation and ensure traceability. Project management capacity will be also important. You have to have a full empowered project manager with a strong team that will have the opportunity, the capacity to secure all aspects of the project, and have also the opportunity to implement required quality or specificities related to our activity in the workshops. This is also the key success factors in order to be able to have a good cooperations. To have a sustainable supply chain, it's not only the local company or the vendor. This is a 3 pillars that will make successful such a program. There is the need from government and utility to provide a clear picture about the program, to support by training, to help the companies to have funding, and the government has a key role to help the local industry to develop itself. Local industry has to be empowered, to be committed directly to implement specific activities to the nuclear. And then the vendor, there is clearly the need to have an experienced vendor in terms of development of local company, as well transfer of technology. So this is a joint effort of the 3 pillars that will make successful the localization program. As a EDF, we are a partner for the Polish nuclear program that has a significant experience in the entire life of a nuclear power plant. You know that we have successfully also in the past been able to develop our own localization program in the 70s, 60s, 70s, when we built our 58 reactors. We are also operating now more than 15 reactors in UK. and building new reactors in HPC. We will also build new reactors in a Sizewell. So we have now a great experience of the construction of new reactors. We are also strong partner in the frame of the engineering training also, that is key. We have capacities in training to support operators and also the local supply chain. And EDF will embark also the full French nuclear industry that has been experienced also all around the world to develop such a program. So we will take benefit from a transfer of competencies, of know-how to the local companies in Poland, thanks to collaborations and implication of the full French industry. It is important to have in mind, that sometimes for nuclear projects are so big that we think that it's mainly big or major companies. In fact, as you can see, we have about 2,500 small medium company. We have some suppliers for strategic activities like cable penetration, for examples, that are in fact dedicated business units with 50 or 100 people. So there is also opportunities for safety classified activities or for standard equipment to embark in the program, small and medium company. So we will be pleased to be a long-term partner for Poland. We have already a strong experience with Polish company that we have embarked as suppliers in Flamanville, for example. If I summarize, I hope that it is clear for you that the key success factor in such a program is anticipations. The anticipation from government and utility, but also from the local company. The anticipation will help us to mitigate the risks. It is key to start as early as possible to set up safety culture, to have a good understanding about quality requirements, and anticipations working closely together will secure a successful project. We definitely are convinced that the Polish nuclear project will provide many opportunities to local companies. Why? Because there is a strong local industry in Poland. There is already an experienced industry in the nuclear. Company, as I explained before, have been engaged in also safety classified activities, already in EPR projects, also in for electrical installation, for example. And we consider that EDF, with our strong experience developing localization program, will help Poland to develop this project with a successful industrializations. If you want to contact us or any companies can take benefit from the address that you can see, Poland Nuclear Supply Chain EDF, we will be pleased to engage with you and to answer to any of your questions. I would like to thank you for listening to the presentations. Dziękuję.
Dziękuję również za tą prezentację i
Thank you very much for your presentation, and as usual, there's a question for you, because we all know that we, as Poland, we really care to get local companies involved in the project, and we also hope to create new jobs. My question will be about the qualification of those companies. I would like to ask, actually, what is the structure of subcontractors for EDF in France? And when you work on those projects that you already have in the pipeline abroad, are those mainly small and medium companies, or do you rather work with big partners who in turn subcontract on their own? And here there's another question, a supplementary question: how do you actually screen the competences and do you control those subcontractors when they are involved through very big companies?
Concerning the first questions, we adapt our industrial scheme to the customer expectations. So if I explain to you the industrial scheme that we have in France or in UK, we have different approach. And for sure, we will have an industrial scheme where we will engage with a major company for activities, and we will also involve small and medium companies as subcontractors. We adapt our scheme also in the project. If I take the example of HPC, we have adapted our industrial scheme concerning the installation work. So we have identified during the project construction that it will be more efficient to change our contractual scheme by merging all activities related to HVAC, mechanical, installation work. So we adapt towards the project, local expectations, and towards the construction phase, the industrial scheme, the contractual approach that we will have. So we will contract, as you have seen, there are some major work package like nuclear island, conventional island, BOP. So there will be opportunities for EPC contract, and there will be opportunity for supplier to provide equipment or installation work. We have to adapt also our strategy to the capacities of the local market and the size of the company. So for some activities, and depending on the capacity of the local companies, we can, for example, take one company for the as an EPC contractor for the BOP, or we can have to decide to split the BOP into 4 or 5 different subsystems that we will subcontract to local companies. So to summarize, we adapt ourselves to the expectation of the customer as well to the capacity of the local companies. To the second question, so we have a qualification process that we apply. I described to you in my presentations the anticipated approach that we have with pre-qualifications. This allows us, and especially the newcomers, to have a good understanding about the qualification requirements. It's a good way to anticipate and to ensure that, in fact, the qualifications should be successful because they will have anticipated our requirement. So, as it's we have tools and methodology to qualify the company, the local company. After the qualification in fact, the qualification is for a duration of 2 years. After 2 years, we have to renew the qualifications. And when we are under a contract, when we are in the frame of an agreement, we will follow in the frame of the agreement the quality and qualification of the supplier. So we have dedicated quality and inspection team that will continuously interact with the company. As explained, we will qualify the company for one project. This qualification is set up for 2 years, and if there is new activities, it has to be renewed after 2 years.
Bardzo dziękuję za tą odpowiedź.
Thank you very much for this answer. I really hope that Polish companies will have the opportunity to join this group. If I don't forget 25,000 companies that you are already working with. And I hope that there will be a lot of Polish companies in our nuclear project. I hope that this is not just my inborn optimism here.
The same approach. So we have 25 companies that are already engaged for different activities, engineering, equipment, construction, and we are definitely confident because we have already engaged for many years now localization program in Poland. So we have a clear vision of the Polish industry, and we are definitely confident that the expected localization content of this program is possible thanks to the fact that you have a strong construction company also. We are really confident also that we will be able to have Polish company involved for safety classified activities.
Dziękuję.
Thank you very much for attending our seminar. I hope that there will still be an opportunity for us to meet. Once again, thank you, ladies and gentlemen. I would like to invite you for a break. We are going to meet after the break, and let me just remind you that you'll still have the opportunity to ask questions to our guests and panelists. Even if any of those questions is not asked here during our session, you will also have the opportunity to get an answer, to review the answers through our website, where we are going to post a report from this conference. Thank you very much, and now please enjoy your break and see you after the break. Good afternoon, ladies and gentlemen. After the break, I do understand that the break was a short one, but I believe that you were efficient in your relaxation, that you were able to catch a short breath. It's my great pleasure to welcome you to the second part of our webinar. We already have meetings arranged with additional panelists and their presentations. I'm going to get to that in a moment. But traditionally, I would like to encourage you to ask questions to our guests, to our panelists. I will surely ask some questions here directly, but all those questions that you do not get an answer to during the seminar will be published on our website. And now I'd like to welcome our next guest after the break. This is Mr. Othman Salih, who is an external expert of the International Atomic Energy Agency. Welcome. I hope that you can hear us and that you can see us. And the title of this presentation is Localization of Supply of Nuclear Program Product, Products and Services Based on a Global Experience. The floor is yours.
Good afternoon. During this presentation, I don't hear much. During this presentation, I will try to present you two reference cases of project countries where a localization process has been conducted. Namely, you will see it's in Korea and in China. I will try to derive from these two experiences feedback and takeaways, as well as recommendations, for the preparation phase, the role of government and chambers of industry in this process, and also the aspects of which are very important of, and the former speakers have already insisted on that, the aspects of the training and the technical assistance. So, as I said, the first example is the example of the project of Ulchin 1 and 2 in Korea. Mr. Kum gave you this morning the global picture of the Korean program and from the start to the end, which means to today, to full self-reliance. This project of Ulchin 1 and 2 was a pivotal moment for the Korean nuclear program. It included extensive manufacturing localization and extensive nuclear-grade equipment manufacturing localization. After Ulchin 1 and 2, with the further projects, the Korean program acquired a reactor license and reached, as Mr. Kum explained to you this morning, the self-reliance. The localization program for Ulchin 1 and 2 associated both engineering technology transfer. It was the engineering technology transfer to what the subsidiary of engineering subsidiary of KEPCO, who was at the time named COPEC and now is named KEPCO Engineering, and included also nuclear-grade components manufacturing. There was limited manufacturing localization for the two previous units of Kori 3 and 4, which took place, but it took place with the main beneficiary of this localization was Hyundai Heavy Industry. And you will see that there is the beneficiary change from Kori 3 and 4 to Ulchin 1 and 2. So, first, the engineering technology transfer. Several engineers from this engineering subsidiary of KEPCO were integrated, in fact, for periods of 2 to 3 years in the Framatome team in Paris. You see the detail of the technical topics in which they were involved. As for the equipment localization itself, there were three cases. We can consider three cases for the equipment. The first case is equipment where the assistance of the vendor was not needed. In some cases, like primary pumps, for instance, were in case 3, that is to say, they were entirely manufactured. There was no localization of the primary pumps, for instance. And in fact, the method of procurement which corresponds to the localization process is the case 2. In this case, Framatome was providing the detailed design and the shop drawings, and also, for many of the localized equipments, parts which were manufactured in France and then assembled in Korea. At the end of that, the process, the percentage of localization actually reached on the value of the nuclear island equipment reached 41%, which is, you see, a little bit more than the target of 38%. In the Doosan plant in Changwon was carried important nuclear components, the completion of important nuclear components such as reactor vessels, steam generators. These operations were most oftenly carried out from sub-assemblies which were manufactured in France and then shipped to the Changwon office of Doosan for final assembly. And this with a very important technical assistance in order to train the Korean personnel to the technicity and the quality standards. By the way, I just mentioned that there was also on the conventional island side a localization program which took place with Alstom. And for instance, in the frame of this localization program of the conventional equipment, the assembly of large conventional components like the turbines, the generators, the condensers was also carried out in the Changwon workshops. As Doosan specialization was and is today also in heavy mechanics and boiler making, the localization program had also to turn to other Korean suppliers in order to meet the requirements of the contract in the other areas of manufacturing. These operations have also led to a significant transfer of technology between French and Korean suppliers and have, in some cases, led to lasting industrial relations. Therefore, it is through relatively complex industrial schemes that equipment as diverse as diesel emergency generators, electrical cables and cable trays, the assembly of electrical panels, certain cooling units, the main pumps of the engine rooms, overhead and polar bridges have been manufactured in Korea. As I have already mentioned, there was an important transfer of technology. This transfer was carried out both by training the Korean technicians in France and by the secondment to Korea of highly qualified specialists, all accompanied by a considerable transfer of documents. The follow-up of these local productions required a net increase in the design, purchasing, and quality control services usually required for such orders. These various measures represent, of course, a cost, an additional cost. They have, however, made it possible to obtain generally very satisfactory levels of quality for the materials, and this for within normal lead times of manufacturing. The second example I will try to show, to detail briefly, is the project of Lingao 1 and 2 in China. You know, there was, before Lingao, there was the construction of Daya Bay 1 and 2, but there was no manufacturing localization for Daya Bay 1 and 2. For Lingao 1 and 2, the Chinese authorities and the owner-operator CGNPC, decided that this project would be accompanied by an extensive program of manufacturing technology transfer and an acquisition of industrial self-reliance in this field of nuclear-grade components manufacturing. And this was a political decision, of course, at the national level, in preparation of the future Chinese nuclear program. Chinese nuclear program that you know, which is very, very active today, the most active in the world. To meet these expectations, Framatome, with the support of its main subcontractors, European subcontractors, so that not only French subcontractors, launched an intensive research campaign in 1995 to find the best Chinese suppliers in order to manufacture equipment in compliance with the European quality standards, and with which a long-term agreements could be set up. Meetings were then held with the selected Chinese suppliers. Objective of these meetings was to assess the risks and to determine the needed investments. Actually, during this process, some Chinese suppliers backed out before committing to the project. It is something which is useful to keep in mind. The Lingao localization program focused particularly on highly technical nuclear equipment and primary components. It was mainly implemented on the Unit 2 of Lingao. The project of Lingao included 2 units, 1,000 reactors. So it is on the second reactor, Lingao Unit 2, that the localization program was mainly implemented. And this for the following reasons. 3 following reasons. 1, to have sufficient time to set up the technical assistance and training programs. 2nd, to enable the Chinese manufacturers to draw up the technical documents and carry out the investments and qualifications needed. And the 3rd reason is to have enough time to resolve any problems without getting behind on the project schedule. So, if we take the example of Dongfeng Boiler Works, which was, on the Chinese side, the main subcontractor, the main beneficiary of the main recipient of the localization program, the Saint-Marcel factory, which is the factory which manufactures in France, Framatome factory which manufactures in France the primary components, reactor pressure vessels, the steam generators, provided during 52 months permanent representatives and short-term specialists in the Dongfeng factories in China, both for the technical assistance aspects and for the supervision and inspection aspects, because both aspects are necessary. Then I will try. You have the transparency. You have a summary of the common difficulties encountered with the Chinese supplier. I will not comment it as difficulties, but as already, I would say, feedback and takeaways. The Lingao localization took place 20 years ago. Today, of course, the communication means are quite different and widely more efficient than they were 20 years ago, with internet, with the email, and with data, numerical transmission of technical documents, of drawings, of everything. However, from this experience, some points keep all their relevance. For instance, the clear separation between non-nuclear and nuclear fabrications in the same shop. Proper implementation of quality assurance. Because the localization of manufacturing nuclear-grade components and equipment will be implemented in existing factories in Poland, factories which are already manufacturing non-nuclear grade equipment and components. And this, I have seen that Mr. Pierre-Olivier Coutet has already insisted on that, and I will insist too. One key word to keep in mind is anticipation. The success of a localization program relies quite a lot on anticipation. Even if the local manufacturer staff has been given trainings in the preparation phase, it still has no practical experience of nuclear grade production. Even with anticipation, even with the training performed beforehand, there is still not the practical experience. Practical experience is got in the factories by manufacturing. For this reason, the technical assistance from the vendor side should be the most important, the more important in volume, at the beginning of the manufacturing process, rather than at the end of the manufacturing process. And also, you see the example of the two manufacturing sites of Dongfeng, which with the transportation of parts from one side to another and so on, which brought a lot of difficulties. Important point is to properly assess beforehand the logistics of the manufacturing process. Then we come to, I would say, the general view, the recommendations on the general view of the definition and preparation of the localization program. First, clarify in terms of scope the national governmental objectives. I have tried to identify three cases. In the first case, there are cases where in a country only one or two reactors are planned. For instance, it's the example, for instance, of Slovenia, which has only scope as one small country having only one reactor. It was the case in Taiwan, for instance, because each time they had a pair of reactors constructed, and there was quite a lot of time between the construction of one pair and then the construction of another pair. And they took different designs. The first one was from Westinghouse, the second one from General Electric. So there was no consistency. And they didn't need. In this case, a localization limited to the non-nuclear scope can be considered as sufficient, because with all the non-nuclear scope, you can localize. In fact, the local economy can contribute to up to 30% of the value of the project. Then non-nuclear scope means all the general infrastructure, all the non-nuclear civil works, all the commercial supplies and erection. This is the maximum, including the turbo generator when it is possible to localize the turbo generator and the turbo generator condenser in the country, which is the case in fact. Then the second case is when it is foreseen a program of 6 to 7 units. Then in this case, it is worth, or maybe worth, considering some nuclear grade auxiliary equipment localization. That was done by in Belgium. Belgium has, has constructed seven reactors, which is, however, a small country. So they localized part of the nuclear grade components for at the time, they constructed reactors of the 7 reactors of Doel and Tihange. And the last case is when the localization is in preparation of a wide national program and of a preparation of a self-reliance. And then this kind of localization usually focuses on the primary components. And the two examples I have presented you enter in this category, of course. would summarize this transparency in three main messages. First, the global picture of the localization program roadmap must be made fully clear by the government and the owner operator to the local industry. The local industry must clearly understand the picture and as soon as possible. The second is that of prime importance are realistic assumptions and realistic schedules. Very, very important. And the third message is again, anticipate. Anticipation is the key to the success. So, again, I will summarize this transparency by saying that particularly the staffing in the factories, at the manufacturer's level, the trainings and the funding, the implementation by the government, by the authorities of the structure of the funding of the localization must be anticipated as much as possible. One last recommendation, which is worth saying. We talk about in localization, we think about very much about high technical or nuclear grade component, equipment and services and so on. It is useful not to forget all the support activities and to include them in the global roadmap that the government and the owner operator establishes. These support activities represent a big amount of money, and maximizing the local contribution to them is very beneficial to the local tissue. And I would like, with that, to thank you very much for your attention.
Thank you very much, and I have a question related to the last part of your presentation. Let's just wait for a second. Can you hear us? Can I continue? I have a question about the last part of your presentation, because you said that it's very important for the government to explain the localization program, to have realistic I'm sorry, but I get overlapping audio from the speaker. I can't. Could you please extend this? How should this support provided by the government, should it look like? Support for a localization program, support for companies, support for the industry. What could those companies interested in participating in a nuclear program, what could they expect from the government?
First, in fact, you have two questions, and one question is the clear picture. But it is impossible for the industry, of course, for a manufacturer to involve itself into such a program without having a very clear idea of the picture of the program, of the localization program, and a clear commitment from the government on the owner operator. It is clear. The second is that in such programs, of course, the manufacturers cannot bear all the cost of investments, improvements, I don't know, of toolings, of cranes and many things like that, and even the trade, for instance. So, in general, there is a structure together with the roadmap of the government and the authorities. There is a structure of funding, that is to say, contributing by funds to support all these investments. And this frame, which is part of the roadmap of the localization plan, which must be implemented and as early as possible.
A co to znaczy w pana opinii?
And in your opinion, what does it mean as early as possible? How would you understand it if we are planning that construction will be completed by 2036 in Poland? Then when should we start doing this? Is this already the stage when there is no other option, when we just have to do it?
As early as possible. The schedule must be established, retro schedules from the date where the manufacturers are supposed to begin manufacturing. And they must be ready to manufacture. To be ready to manufacture, they need what? They need to have implemented the investments, physical investments, necessary physical investments, and they need to have staffed and trained their personnel, and as I tried to highlight, particularly the personnel of their design offices, the personnel of their quality assurance and non-destructive examination departments. All that should be already done the time they take an order and begin to execute the order and to manufacture. And so these detailed retro plannings which need to be prepared, to be analyzed, and so I suppose that some of this work is already going on in Poland. Anyway, this is the kind of preliminary work which needs to be performed before any contract with a vendor.
Thank you very much for participating in our seminar. Thank you very much for answering our questions. I hope to see you soon. Thank you very much. And now we are moving over to our next guest. This will be Witold Strzelecki, who represents 4Atom from Brussels. The title of his presentation will be the current state of nuclear energy at the EU level, European nuclear industry's perspective. Good afternoon, Witold. Good afternoon. I hope you can hear me. I'm happy to be able to take part in this presentation. I'm happy to be able to briefly present the outlook, the state of play of the nuclear power industry at the EU level, what are the development perspective and what benefits are brought about by the nuclear power from the point of view of the industry and companies that would be interested in getting involved in this project. Perhaps initially, let me just briefly say who 4Atom are. We are the international association that represents companies from the European Union from the energy sector, and we work to discuss, to talk with the EU institutions and our decision makers in Brussels in order to develop solutions that would take into account the power industry, but also support investment into low emission energy sources at the level of the individual member states. 4Atom represents more than 3,000 companies from the entire European Union, from such countries as these are represented through national forums located in 15 countries. We also have 3 individual members. This is CES, Fermi Energia from Estonia, and PGE-1 from Poland. So a company that is also represented by us in our discussions with the EU institutions. The scope of topics that we handle every day is quite extensive, as you can see in this slide. This depends on what the current legal acts are being processed at the EU level. I would say that to the main extent this is a focus on the energy policy of the European Union, but also we are involved in R&D topics, safety, transport, all those topics that to some extent refer to nuclear power. And you can't forget about communication, so those areas that are gaining importance right now. So we also operate to build awareness of the benefits of the nuclear power, and also building the image and perception among decision makers, the media or the public, which to a great extent impacts the place of the nuclear power in the individual legal acts. Before moving over to a detailed in the European Union, I would like to very briefly discuss the outlook, the current state of play. As you can see in this map, currently in the European Union, there are 107 nuclear reactors operational, located in 13 member states, and a lot of these member states have a considerable share in the energy mix. This is almost 20-30% of electricity. This is quite an important share, which should be stressed. If we only take into account low emission sources, then nuclear power is 50% of the low carbon electricity, which in the context of planning how the European Union could actually decarbonize its electricity supply system is an important tool for achieving this goal. And you can also see here there are 4 nuclear projects in pipeline: Finland, France, Hungary, and Slovakia. A lot of other member states are considering investments in additional reactors or building the very first reactors like Poland or Estonia. If I were to briefly discuss the division of forces in the European Union in terms of countries that support the development of nuclear power or those that actually don't see a future for the European Union that would be associated with this source of energy, you can see this here on the slide. There's a lot of countries that are pro-nuclear, but most of them are not that active at this EU level as some of the countries that actually negate nuclear power, such as Germany, Austria, or Luxembourg. Those states are quite actively opposing the inclusion of nuclear power into the individual legal acts. If we're talking about the EU institutions, it should be stressed here that just the European Commission, which proposes the individual legal acts, is not very enthusiastic about including the nuclear power in the individual legal acts. And we as Foratom and the member states already mentioned here, we are lobbying quite strongly to have nuclear power claim its place in the individual legal acts. If we're talking about the future of nuclear energy in subsequent years, which I think is important, is especially important from the point of view of companies in the industry that would like to get involved in nuclear projects, not only in Poland but also throughout the European Union, it's worthwhile to mention about
dobrze widać na tym slajdzie, natomiast slajd i ten w lewym górnym rogu pokazuje.
I'm not sure if it's clear on the slide, but in the upper left corner it shows the CO2 emission levels in the individual EU countries, what is the average and what it should be if we assume the assumptions of the European Commission for climate goals for 2050. Then you can see that a lot of countries still, including Poland, they have a long way to go, because we as Foratom are promoting nuclear power as the tool that will allow to achieve the climate goals, where those countries and Poland will be able to meet those goals. So looking at climate matters as the IPCC or MIT from the US, what is the European Commission saying about this? I think that we should refer
dotyczącej redukcji emisji gazów cieplarnianych.
The long-term emissions reduction strategy in the European Union that was presented towards the end of 2018. As you can see, European Commission is quite clearly showing that renewable energy sources and nuclear power will constitute the basis of the zero emissions energy system in the European Union, and installed power in the nuclear power by 2050 will be at approximately 120 gigawatts. Right now it is approximately 110, 100 already after accounting for the Great Britain leaving the EU. This document has already been also presented when Great Britain the UK was still in the EU. Why is this important? It's important because if you look here in this chart, you can see quite clearly what will be required if in the EU
jądrowej na poziomie zbliżonym do tego.
we want to keep installed power in nuclear power at a similar level. Those blue bars are the current capacity in the EU without the LTO, so the extension of operating times of nuclear powers, yellow bars are added through LTO, and the green bars are the power that we need to add through entirely new nuclear power plants. As you can see in the perspective of 2050, this is more than 100 gigawatts of installed power, which is going to have to be created in the European Union so that we can meet We should also mention here how this nuclear power industry will develop in the European Union in the next years. This graphic presents national energy and climate-related plans that each of the member states was required to submit to the European Commission. As you can see, 16 countries out of 27 are taking into account, to a various extent, nuclear power. Whether these are new builds or LTOs or research and development. So for sure we are going to look into the development of the nuclear power at the EU level. There's a lot of initiatives in the European Union looking into the place of the nuclear power industry in the subsequent years. Without going to details of all of these initiatives, that's the European Green Deal. So a set of legal acts for them that is going to create this EU economy for subsequent years, retaining a sustainable development and shaping it to be able to respond to the challenges that the EU faces. And we as 4Atom are intensively lobbying to have those different legal acts under the European Green Deal to account for nuclear power and to promote investment in these low emission sources. Another important element is the Next Generation EU, that is a program to recreate the European, rebuild the European economy following the COVID-19 crisis. As 4Atom, we are lobbying strongly for the nuclear power industry to be one of the key industrial sectors to be accounted for appropriately and taken into due account, among others, because of the benefits it brings in terms of creating jobs and economic development of those countries that decide to use this technology. And the third program is the EU Industrial Strategy, so another document that was presented this year at the EU level. Of course, this document and its execution is also meant to reinforce the EU economy, and we as 4Atom are also working to ensure that in this case the nuclear power industry is present and is promoted by European institutions. If we were to focus on the benefits of nuclear energy that we as 4Atom are promoting in the discussions with the individual EU institutions, this is for sure energy security, this is for sure the benefits that were already mentioned, benefits in fighting climate change, and the third key element are economic benefits for the economic growth of states that decide to invest in this technology and to commit their futures to this. Now let me just briefly focus on this third element. Last year Deloitte drafted upon our request, a report showing of what the benefits, the economic benefits would be of investing in nuclear power. The key results were that currently in 2019, at the time, the nuclear sector is creating more than 1.1 million jobs, 47% of which are highly skilled. So the EU, the nuclear sector, each year it contributes to approximately more than 500 billion euro of the total GDP. And the difference of export that was generated here beyond the EU and import of foreign companies into the EU, this is 18 billion euro. Here it should also be mentioned that from the point of view of the Polish project, according to the Deloitte analysis, 1 gigawatt of installed nuclear power generates more than 10,000 jobs, and this income in the individual states at approximately 4.3 billion in 4 billion euros. In this chart, you can also see what the distribution is in the individual states in terms of jobs and the benefits from the point of view of GDP. But I also think that it's even more clear in this map, where you can see that not only those states that already have nuclear reactors are benefiting from this technology, but right now in Poland there are more than 12,000 jobs in the nuclear sector. Polish companies are involved. Also in projects in the Belarus, in France, in Russia, or in the Ukraine. So I think that the experience accumulated to date is already quite extensive, and it will surely benefit the execution of projects in Poland and then in other countries. As I already mentioned, nuclear investments over the next few years, there will be a lot of such investment projects in the EU. So experience will benefit all these future projects. This is also an element of the analysis published by Deloitte, which was drafted for our needs. If actually in the next years there would be more than 100 gigawatts of new power in nuclear power plants in the EU, according to our analysis, apart from what I already mentioned, this will also generate an additional 200,000 jobs, additional 70 billion euros in total GDP at the EU level, and the trade surplus within the EU at plus 15 billion euros. It should also be noted here that even though right now most of the jobs in the nuclear power industry are involved in the operation of plants that are already functioning, then according to our analysis, in the future there will be more jobs in construction of new power plants, which is evident and results from the chart that I already showed you. We should also quite clearly state that if we compare the nuclear power industry to other low-emission energy sources such as wind power or water power, from the point of view of states that decide which direction to pursue in terms of investing in decarbonization, nuclear power looks most promising. In terms of creating jobs, you can see that the differences are quite considerable, but also the income generated for this investment mainly results from the specific nature of the individual investment projects, which work differently when building nuclear power plants and building wind turbines, as I mentioned. This is one of the key elements in the EU economy. This is the second biggest industrial sector in the EU, right after the construction sector, And in terms of jobs itself, I think this should also be stressed that investment in nuclear power benefit not only the nuclear industry directly, but also a lot of other branches of the industry. According to the analysis by Deloitte, every job created in the nuclear industry in the EU creates 2.2 other jobs in other sectors. So this should also be considered when planning and deciding to invest in this source of low emission energy. Just let me still stress that apart from this obvious set of benefits for the economy in terms of jobs, revenues, we should also stress that investing in nuclear power means quite considerable transfer of technology, development of innovation, as well as benefits in terms of education that will be required in order to ensure that the staff in this sector will be properly qualified. As I mentioned, right now almost 50% of jobs in the nuclear power sector are highly qualified jobs that require appropriate level of education. And just to summarize, let me briefly say why, in our opinion, as for Atom, the next years mean that there will be dynamic development of nuclear power in the EU and in the individual member states, and why, from the point of view of the industry, to get involved in those projects in the future. First of all, the EU will have to use nuclear power to meet its decarbonization goals, its climate goals, energy goals. This is not only extending the operation of already operational power plants, but also building new ones. As I mentioned, many EU member states include nuclear energy in their plans, energy plans for the years to come, so there will be more and more of those investment projects. Nuclear power means the security of energy supply, decarbonization, but also economic growth, both at the national, regional, and local level. For example, 1 gigawatt in a new build reactor means 10,000 direct and indirect jobs. Also, the nuclear industry means transfer of knowledge, innovation, and education. So all those elements that may then be used by companies also in future projects. So that's all I wanted to say. If you have any questions, I encourage you to contact Foratom, and I will be also happy to take any questions you might have right now. Thank you very much, Mr. Witold, for this presentation. I would like you to perhaps say a few more words about the lobbying activities that you are taking, but also a question from me that one of our audience, members of our audience asked. Perhaps let me rephrase it a bit, because you mentioned this very strong position of Germany, and what is not a secret, because already several years ago the Germans decided that they will be closing nuclear plants by 2023 after the Fukushima disaster. We know that Austria is also negative about those projects. To what extent those countries, let's say, anti-nuclear countries, to what extent is their position strong, and can those programs that have been included in those post-COVID strategies, to what extent is this possible to actually get all those nuclear projects done? Do you think that the vote of those anti-nuclear countries, can this be strong, or not because there is no other way to do it, because since the nuclear industry is included in key EU elements, there is no way back. So the voice of those anti-nuclear countries will not sound as strongly as you could think it did several years ago.
Dziękuję za to pytanie.
Thank you very much for that question. I think that it's worthwhile to emphasize and to refer to what I mentioned already, that despite these atom countries in the European Union are more in numbers than the ones who are anti. But I think the anti ones are more active, definitely more active. They were definitely more acting against and trying to block nuclear investments in individual countries, which is actually opposing to the fact that each country can. But there was also a reference to the fact that you can impact the environment. So those countries that are object to building nuclear plants could have taken a voice. If this is related to impacting the environment, yes, but also in the case of Hinkley Point C, Austria tried to block that quite intensely. What's worthy of emphasis right now is that more and more pro-nuclear countries actively and more loudly are expressing their opinions at the European level that from nuclear energy will be a key factor in terms of the fact whether these countries are to reach their decarbonization, EU decarbonization goals. And I think that's worthy of mention. Poland also, which in recent months has very actively aspired that nuclear energy, the place of nuclear energy be taken into consideration. So even though many countries had nuclear power plants, were clouding it more, promoting it less actively or intensely, and I think that trend is changing in recent years. And this is also probably a result of the fact that many countries realize that without nuclear energy, that realization will not be possible. So that's why they are opting and fighting for it also at the EU level. Does that mean that there's no return and there's no going to be any strong impetus to block because the situation is changing? I think the attempts to block will happen, and it's visible especially in the example of Austria, where as much as possible it tries to block any nuclear project in the European Union wherever it's possible. But I think this balance of power has changed, especially the CEE countries are saying almost unanimously that nuclear energy will be expedient for them, necessary. So I would say that if, as Foratom, we were to speak about it, then I think that there is no return from nuclear energy. Contrary, I think European Union institutions are more and more going to look at that source of energy with a kind eye. So I understood, Vital, that this is a lesson for us, that we shouldn't be concerned or worried about the opposition, and the plan of building the first reactor in 13 years is realistic. Yes, that's what I believe. I think it's realistic and consistent with the objectives that the European Commission is setting ahead of, putting in front of members. Thank you very much, Vital, for your participation in the seminar and your presentation. Ladies and gentlemen, now we would like to invite the next guest, Mr. Bruno Marquis, from the French Association of Nuclear Codes. And the title of the presentation is Importance of Nuclear Quality in the context of the nuclear supply chain, codes, norms, standards from the French AFCEN perspective. Welcome.
Widzimy się i słyszymy.
Welcome everybody. I hope you can hear me very well. I have some return. Okay, thank you. I will give you a presentation related to the importance of nuclear quality in context of nuclear. So my presentation is into four parts. One is after a little introduction, I will present you the nuclear quality in organization. Then I will discuss about the nuclear technical requirement, and then I will finish by a conclusion. So, what I want to say first is that the nuclear quality in the manufacture of nuclear power plant equipment is mainly based on two pillars. One is related to the organization within factories, especially the quality management. And the second is a high technical know-how, including the traceability of verification carried out. So the challenge for any company that wants to penetrate the nuclear equipment markets is therefore to strengthen itself on these two pillars. So I will give you some example on these two pillars regarding the French experience. So regarding the quality management, there is a new standard issued by the ISO 19443, which is a specific requirement for the application of the ISO 9001 by organization in the supply chain of the nuclear energy sector, supplying products and services important to nuclear safety. So this standard newly issued is very dedicated for the nuclear systems and is already used for future new build projects. So the ISO 19443 is applying to organization supplying important to new products and service as contractor or subcontractors, and is not intended to replace the regulatory requirements, but is designed to help to comply with them. So the major nuclear players are leading now to adopt this ISO 19443 in the nuclear supply chain in Europe. As an example, EDF, the French operator, requests a conformance with ISO 19443 for all level 1 suppliers involved in the future new build project, like what we call the EPR2. It's a very important and sound signal for the European supply chain, which be aligned with the standards in the coming years. And so for newcomers to the nuclear industry, they should pay close attention to the requirement of this ISO 19443. Where it comes from? It's based, the work group who works on this ISO 19443 was inspired by the aeronautic and space industry because it's a similar context, a strong safety requirement. We need a high quality and industrial expectation combined within a process and the low production volume. So the idea was to harmonize some specific requirements into largely deployed standards. This standard is an ISO 9001. So we use two major nuclear references, from IAEA, the GSR Part 2, and from ASME, the NQA1. And then we had some industrial experience and feedback from recent construction and project, and then we create a specific requirement. These specific requirements were added to the ISO 9001, and then this document was called the ISO 19443. So that standards had some requirement to ISO 9001, mainly on the quality management program, on the safety culture, the nuclear safety culture, the classification of ITNS, the graded approach, cascading the requirement through the supply chain, the counterfeit, fraudulent, suspect items, the management of this, independence of verification, the competency management, project management, suppliers assessment, the design control, and the procurement control. So you can, if you open the ISO 19443, you will see that the basic is the ISO 9001, which deal with the quality system, and is replicated. And then you have some slight adaptation to complement with nuclear specificity in some parts, and also for some articles is envisioned to comply with nuclear specificities. But all is in the document. The ISO 9001 plus the specific requirement is used. So in addition to the ISO 19443, the ISO work group also create two other documents. One document is related to the bodies providing audit and certification. That means if you want to be certified according to ISO 19443, you will ask some bodies to provide this certification, and these bodies have to be compliant with the ISO TS 23406. And then you have the guarantee that the certification is it's quite the same wherever the country is used. The ISO TS 23406 is based on the ISO 19021 and provide additional requirement. It's the same idea than the ISO 19443. And in addition to these two documents, ISO also create a guide for the application of the ISO 19443. So with the ISO TR4450 is quality management system guidance for the action of ISO 19443. It's very interesting because this technical report provides additional information on the ISO and give examples of application in some informative appendices. This information appendices are like, for example, how to perform a risk analysis for the project, how you can determine the ITNS items and activities, what they give also practical example for the definition of these items and ITNS item and activities, how to manage a graded approach about the requirement through the supply chain. So with this informative appendices and with these three documents, the ISO organization provided tools to nuclear industry for the implementation of this ISO 19443. And I guess it's a great help for newcomer if you can use or manage kind of requirement, and also if the vendor requests application of the ISO 19443. Then I will switch to the second part of the presentation, which is related now to the technical requirement. So this second part deals with the control of the technical requirement required for the production of nuclear equipment. I will explain that the IAEA requirement clearly call for code and standard as a proven engineering practices, technical field like mechanical, electrical, civil engineering, fuel design, etc. These code and standards are called the nuclear codes, and they form a very small family in the world. Very limited choices offered to the nuclear vendors. And I will give an example of the mechanical fields. And then I will illustrate this by one of these nuclear codes, which is and I will show you that, for example, has other trusts they strongly rely on the ISO and EN standards. So if you have a look on the IAEA safety standard, like the safety of nuclear power plant design, which is the SSR2/1, you will see some requirements clearly calling the nuclear code and standard, like requirement 9, proven engineering practices. They say item important to safety for nuclear power plant shall be designed in accordance with the relevant national codes and standards. And also another requirement, which is requirement 18, the engineering design rule for items important to safety at a nuclear power plant shall be specified and shall comply with the relevant national or international codes and standards and with proven practices. Then the vendor shall apply a proven nuclear technical code and standards. very few codes exist. And for example, just to highlight what's happened in the mechanical fields. So in nuclear code in the mechanical domain, from a very small family on a world scale, you have the US code, the very well-known ASME code, and its DERA code, because they are very rare and explicitly refer to the ASME code, such as the Canadian code, the CSA, the Korean code, the CUPIC, and the Japanese code, the GSM. Another family is the Russian code, and the third one is the AFSEN code. There is no nuclear program in the world without this reference code, because it's an element of sovereignty and the support of a technology. So you can see on the figures how the market is shared between the different mechanical codes using in the nuclear units under constructions, and 30% apply the RCCM, especially in France and in China. And ASME, RCCM, and the Russian code have the international recognition because they are used in at least three countries. Another interesting things regarding I will now enter more and more into the AFSEN codes. So I select 3 of them which are used during the construction plants. And all of them are mainly based on the ISO and the EN standard. The RCCE, which is for the electricity, there are 85 standards, CO or ISO. For the RCCCW, which is the civil work, there are 88 standards coming from CEN or ISO. And for the RCCM, the mechanical have 72 standards coming from CEN and ISO. Large, what is different AFSEN codes? We can see that there is 37 codes using editing by AFSEN. One is related to fusion, fast and experimental reactors in the mechanical domains, and the 6 other are related to the PWR reactors, these domains. All these codes are up to date now because they have some edition in 2017, 18, or 19. All are in French or English. And you can see on the bottom the list of the experts who are involved in these codes, which is a vivid community of experts working on these codes. Then I have a long history of development of code because they are created in 19. And they accompany the French nuclear field in different projects, and especially in China, because during the 80s, one of French plants were implemented in China with the Diabe. And so the AFSEN codes were coming with this plant, and the Chinese nuclear program was started the AFSEN code, and now it's mature and independent. And the Chinese nuclear operator engineers have a great knowledge in AFSEN nuclear code, so they can directly apply the code from their own project, which is Hualong 1. And AFSEN have a user group which is in operation since 2014 in China. So it's a great example of the appropriation of the codes by the local industry. Another example is what's happening in India now, because there is a project in perspective for the French, for France. And I've since begun with EDF, the localization program. And among various actions, the training on RCCM code is provided to major potential suppliers to make them ready to bid and participate to the Jaitapo NPP project in delivering the safety class equipments. So this is 2 examples of successful localization regarding the AFSEN code. So just to say, the AFSEN code, European codes, which are acknowledged has nuclear technical code. They are accepted by 3 European safety authorities, which is the UK ONR, the Finland STUK, and the French ISN. They includes improvement to take into account the local regulations. So for example, in UK, we have regulation for firefighting, which is included in our codes. And we also use a workshop, which is the SEN workshop 64, which is open to all utilities in Europe, vendors, research center, and safety authorities who want to propose involvement of in order to subject and to serve the maximum of future users. And then the code can take into account some local specification or some local demands regarding some specificity for some project. So Polish experts and safety authority are welcome in the CN workshop 64. So I would say, in a conclusion, that the nuclear quality in the context of nuclear supply chain is a key factor for a successful localization. For sure, it needs a large anticipation from the Polish supply chain, but it also depends on the requirements selected by the selected NPP vendor, because give you an example of the one who French can select, but there is others. French proposal, anywhere in the world, the referential applied for the local supply chain for nuclear are based on ISO and EN standards. We will request the use of the ISO 19443 for management and the use of the AFSEN codes, which are, as I said, mainly based on EN standards and ISO technical requirement. So a key point for the Polish supply chain is to really anticipate the application of this specific requirement, which are nuclear ones. So it's necessary to master them before any bid. So that's the conclusion of my presentation. Thanks for your attention.
Dziękuję bardzo za tą prezentację.
Thank you very much for that presentation, and I would have a question to our guests. Since you are speaking about these various types of codes, is there any opportunity in a relatively near future, whether it's 5 or 10 years, to be able to harmonize these technical norms and standards, nuclear norms and standards, at the level of the European Union? Because we know that some decisions right now are happening at the level of countries, and from time to time there are considerable complications. The question is whether there is a possibility to unify and harmonize these standards, these norms. How do you evaluate that? Can you hear us? No? Hello? Can you hear us? Yes, so there is a question. There will be a question if we can hear each other. The question is, in the European Union, in the near perspective of 5, maybe 10 years, will it be possible to harmonize technical nuclear norms and standards also in the scope of a supply chain? Because we know that right now the decisions at the European Union are frequently taken at the national levels, and that causes certain doubts. How do you evaluate the possibility to synchronize these standards?
Of dream to synchronize the standards at the European level is basically as you said, the requirements are based on the nationals, so it's quite difficult. But vendors propose some standards that can be applied in different countries. the technical codes and the quality management standards can be applied, but they will have probably additional requirements coming from the nuclear safety authorities.
Dziękuję bardzo. Dziękuję bardzo za tą odpowiedź. Dziękuję.
Thank you very much. Thank you very much for your answer and for participating in our seminar. I hope that you will also welcome an invitation to the next seminar. Thank you very much, and I hope to see you soon again. Ladies and gentlemen, now I would like to go on to our next guest, Mr. Thomas Weir, Vice President, New Plant Project Development from Westinghouse Electric Company. And the subject of the presentation is supply chain development for nuclear new builds. I invite you, and I hope you hear us and we can hear each other. Okay, we see each other.
Pleased to have this opportunity to participate in this important session regarding the nuclear supply chain in Poland. I have been involved in the Poland program for many years, and I'm very excited to see the commitment by the government of Poland, but also and equally important is the commitment by the supply chain in Poland and the interest in the supply chain to move ahead with nuclear in Poland, but to also rally the support, recognizing the impacts, the positive impacts that nuclear development will have in Poland and also the surrounding European countries and others. It's a global impact on the deployment of a new nuclear power plant. So this afternoon for you, it's morning here. I would like to talk a little bit about the supply chain approach for nuclear new build, but reference some of the experiences that we've had. As you know, Westinghouse technology is widely deployed worldwide, and most recently, with our AP1000 advanced passive plant, we deployed 4 units in China, which are fully operational, successfully performing exceptionally well. And we are in the process of completing 2 units in the United States, in the state of Georgia, at the Vogtle Nuclear Power Station. And we expect units to come online in first unit in 2021. So my point of mentioning that is having real and relevant current experience, which many of the current OEMs have, is quite important for development of the supply chain. Gaps in supply chain from not building over time and the continuity of the supply chain in a nuclear program creates gaps in skills and capability. So the key is to have continuity in the deployment of nuclear, and I'm very happy to be part of that. And by having these experiences in continuity, we can help, and all the OEMs can accomplish and help in this regard to help stand up a supply chain within the local country and the local context for new nuclear. So I will proceed into a few slides as we talk about this subject. Except my slide is not advancing. There we go. First, I would like to talk about, just quickly, the division of responsibility. It's important to understand, especially speaking with the supply chain, of who is going to provide what products and services. Westinghouse, as you can see, we are the nuclear island equipment supplier, and also the safety and non-safety instrumentation and controls, And related to our design, which is a very important aspect, are modules. We, of course, with our design have migrated from a stick-built approach to a modularization approach. And I will explain more about that later on in my presentation. The constructor, whether it's a construction partner, depending on how it's organized for the project, the constructor is providing and sourcing civil structural commodities such as rebar, embedment plates, of course, piping and cable. And I'm sure most of you are aware of these commodities. So it's a combination of the technology vendor and the constructor to combine and provide a very strong strategic supply chain plan for the deployment of new nuclear. And you will see as I talk further of how that gets established in a nuclear program. I will try to advance to the next slide again. I am trying to click my mouse, but maybe you could help me advance. It's not advancing. Supply chain development. So it occurs over phases. And I've tried to lay out the key phases of development of supply chain here for all of you. And my takeaway on this slide is very important, that the localization strategies are developed during very early phases of project development. It's not after the contract for the technology has been awarded. Depending on the scale of localization, that will drive how early certain elements of the supply chain will be engaged. And I'm going to show you how we look at that. But as we have executed in not only in China and the US, but around the world, we evaluate on every opportunity the local supply chain. And you know, there's many considerations depending on the commodity that we're talking about. As I mentioned in the previous slide, the accessibility for logistics and transportation, which are very key factors. Looking at the logistics routes for bringing in our heavy equipment. But then you have the bulk commodities, which can be much easier deployed to the location of the nuclear site. But we will identify candidate suppliers. We'll do desktop reviews. We'll do supplier visits. We will then finalize divisions of responsibility within the context of the engineering, procurement, and construction delivery. We like to use a best athlete approach between us and the constructor, and also the owner, operator, has a role in the division of responsibility. So we down select, we solicit proposals and move forward. Supplier development and qualification is also a very important aspect, which was just recently discussed, related to the ability of a supplier to meet the codes and standards that are required for nuclear quality. And not just the codes and standards, I want to emphasize a very important aspect is the safety culture, the nuclear quality and safety culture of the supplier. We've had challenges in that in the past of trying to support a supply chain that was not nuclear ready, to work within the nuclear culture, but the rigor and discipline of nuclear deliverables, particularly those of which could be in our safety related or important to safety. And then, of course, we execute the procurement. We then, after doing commercial evaluation, we end up looking at those that are potential candidates for a particular sourcing, and we do our evaluation, final selection. But I can tell you, for some components, depending on the scale of the program, there could be partnerships established where not only you're looking at sourcing for one or two nuclear units, but you're looking at a longer-term partnership and relationship with particular suppliers. So it's a complex program of looking at the overall deployment strategy, working with the supply chain. And of course, many of the OEMs do that in advance, like I'm talking about here. So if we can proceed to my next slide, please. So I won't re-speak the codes and standards, but as you know, there is many codes and standards required for implementation of the nuclear quality requirements, and they were previously mentioned. But of course, we look at these standards applied based upon the design requirements in that particular country, also going through the regulatory process for design approval. All these piece parts come together, and these are just a sampling of the important codes and standards that our design complies to. And we, of course, run a very detailed compliance assessment of our design and reflect those in any specification that would be provided to the supply chain for bidding and quoting on any components associated with our plant. Next slide, please. So our approach, I think this is an important piece. We have taken the AP1000 product and have broken down the commodities into various sourcing types. I think my slide advanced, if you don't mind going backwards. We have commodities that range from high risk commodities to medium risk to low risk. And we have taken, as you can see in these pictures, all of our commodities that make up an AP1000 and have done what we call a supply risk assessment, or a risk-informed assessment of those components. A key point that I would like to make for you is 67% of the commodity codes for an AP1000 are relatively low risk commodities, which says they are the easiest and least risk to be localized. There's certain structural modules, tools, tanks, of course, the bulk commodities, which I mentioned earlier, construction materials. So it's a large percentage of the plant. There's some characteristics on the higher risk commodities that do drive investment on the higher risk items. The large structural modules require some early investment to prototype and test to have the facility to meet those requirements. So I will not spend a whole lot of time on this considering of the time, but I wanted to give the message that it's important to understand the risk profile within the supply chain of delivering certain commodities. But the key takeaway is that 67% corresponds to strong localization potential. If you could go to the next slide, please. So our engagement, supplier oversight is quite important on a project, but it also it's a graded approach. We, of course, depending on the complexity of the component that we're being sourced, we will determine whether we have full-time supplier performance engineers in the shop to, in some cases, low level of support. In our deployment of the China units and also the units in the US, we have ranged everything from complete transfer of the capability to the local country and shop, of standing up module shops, to first of a kind equipment, testing loops with the supplier, and we have demonstrated the requirements that go through the witness and hold points and the level of rigor and detail based on the complexity of that component. So we have a very strong roadmap on how to do that and how to work with the supply chain. But my key point for the suppliers that are participating in today's conference is to recognize and really look at the couple slides that I shared on what I call risk-based sourcing. As an OEM, one of the most important elements is of the project and the delivering for the local supply chain and for the customer and for the country is predictability of delivery and delivery certainty. So you will hear us emphasize as Westinghouse to stay, in some cases, for high-risk components, the incumbent supply chain, those that have delivered the components before. If a country is willing and to invest early enough in certain higher-risk components, we look at those developments of that supply chain for potential localization. But as I mentioned, that 67% is a very important number. The economic impact in the country of localization for that deployment is significant, not just for the direct supply chain, but the adjacent and support services associated with it. So I know all of you know that. I know it's part of the energy programs and plans for nuclear deployment in particularly first-time countries. But I believe that we have to leverage all of our experiences in the deployment of nuclear to help stand up this competency and capability in Poland. And I know Poland has a strong supply chain. We have been looking at it with a lot of capability. So it really comes down to the specifics of the timing, the capabilities, capacity, and the competencies tied to specific commodities within the delivery of a nuclear power plant. So supplier oversight is very important. We view suppliers as partners and integral to our plant schedules, our delivery schedules. So it's quite important that we work together with the supply chain and early. I cannot emphasize enough the importance of early engagement with the supply chain and the suppliers truly recognizing the differences of deploying for nuclear versus non-nuclear applications. This is the systems, the processes, the tools, the procedures within your shops. All of these are quite important. So the rigor and discipline and the culture of a supplier is quite important for deployment of nuclear. Let's go to the next slide, please. So I won't touch on this slide too long, but this is kind of a view of showing the quadrants of structured supplier qualification, the technical assessments, the commercial stability evaluation. All these aspects are so important. Registering the supplier, looking at the nuclear quality management system of the supplier, the technical assessments when we're adding a new supplier and the renewal cycle of renewing a supplier onto our approved supplier list. When we look at the ASL or an approved supplier, the manufactured components with no quality requirements such as tooling and fixing. So we have a QSL, which is for quality components, nuclear quality requirements, as previously mentioned. Those that are on our ASL or approved supplier list for manufacturing of non-quality components. And of course, non-approved supplier quality. These are catalog components. So we basically take our commodity codes that make up an AP1000, and they're put in, and we of course know these now, into these buckets. And then we look at the supply chain, the available supply chain within a particular country, and we look at the opportunities for localization, considering all these factors. And it's quite important for the supply chain in Poland to really understand these processes that a nuclear OEM goes through, and also the constructor. The constructor has one of the greatest opportunities for localization of various commodities, which it's why I showed the division of responsibility to you, to give you a feel for where your company may plug in to the engineering, design, licensing, procurement, construction, startup and test, and overall commissioning of a nuclear power plant. Let's go to the next slide, please. I have two slides about structural modules. I know most of you have heard about modularization. I just mentioned to you that when you look, the modularization is actually a small component of the total commodities of a nuclear power plant for those that have modular designs. But there is no question both nuclear and non-nuclear application of modularization has demonstrated its benefits over time. You can see in the pictures that I'm showing as a large structural module component. These can be 24 meters tall for our large structural modules, ranging from 800 tons to 1,000 tons. So these are once assembled, very heavy lifts, but quite beneficial. One data point I wanted to share with you is in our design, within 3 months of first nuclear concrete, we are setting our first major civil structural module. So when you look back at the impacts of supply chain, these are ordered quite early. These components and the manufacturing elements for a large structural module. But then we do the assembly on site. In the factory, we produce the submodules. We ship them to the site for assembly, and then we outfit, we lift, we set the module, and you can see some of the pictures here. As it relates to supply chain, I want to make one point. We have experienced first-of-a-kind development challenges in the past, significant lessons learned, particularly in the modules area, driven by the tolerances. Tolerances are quite important in the modules, and thank you for advancing my slide. Just to show you a little, shows you the makeup of modules in an AP1000. And as you start to piece together a module, such as the structural module in the middle, you have to be very aware of the tolerances and the stack up of tolerances. And we have overcome those challenges, working with our supply chain and optimizing our design to ensure predictability to schedule and quality of our modules. So we see opportunity for localization and impact of the local supply chain in various aspects of modularization, everything from mechanical modules, et cetera, that we can deploy locally. So as we engage with supply chain moving forward in Poland, please be thinking about the capabilities of your companies. And as we go through the quality requirements to deliver all the elements of a new plant project. And the early engagement is quite important. But we have demonstrated significant reduction in time from the first time units to the nth of a kind units related to the placement of the large structural modules. And we believe strongly that this approach delivers the quality and the predictability necessary for new plant deployment over conventional stick build. And this could be a whole session in itself on construction, but we'll save that for another day. I'd like to thank you for the opportunity this morning, this afternoon, this evening, depending on where you are in the world, to give you a brief introduction, just scratch the surface here with you. We'll be sure to engage further in the future with you, and I'm prepared to take any questions that you may have.
Dziękuję bardzo.
Thank you very much for that presentation. And I have a question on the last part of your statement and presentation. Could you tell us a little bit more about the effects which modularity of the entire investment process brings? Can we speak about very measurable effects of the modular approach? And can we say that the benefits are very specific compared to classical technology or conventional technology? And in the realization of subsequent nuclear project, are you assuming that the effects will be even greater thanks to this modularization?
Thank you for the question. As you know, the data points on a stick built or conventional build from our perspective, go back many years. So we build the AP1000 deployment has been based on the modularization approach. But it's very important in answering this question to separate when we say the word modules. There are large structural modules, which are full buildings that you fabricate in a controlled environment. So as an example, just on that topic, imagine the location of some of the new builds in the weathered environment where you're trying to do stick-built construction and you have weather constraints, only certain times a year, specialty mixes of concrete. We do that in the shop. So when you're doing that in a controlled environment, we know and have demonstrated from the first time deployment to the subsequent units of our module assembly, our module fabrication, shipping, assembly on site in the module assembly building, and then lifting and setting, we have significantly decreased the time to go through that life cycle. Against your comment of conventional build, I could go into long details on this, but conventional build requires the specifics of attachment plates throughout the building. In our design of the modules, that's all completed before you even get to the field. So significant elimination of rework by predefining the modular building, pre-building, lifting and setting versus in the field. So we have seen significant reductions in rework in the field that helps maintain the project schedule by having the entire building. And it ties back into complete integrated three-dimensional design. So these are all very important aspects. But hey, there are designs that are conventionally built. It's specific to each OEM. Our design is built around modularization. Our schedule, our deployment schedule and construction schedule is demonstrating that in our commitments in these subsequent units as it relates to large structural modules. We all know there's no secrets in the nuclear construction world that plants have been delayed. And we have made a point for the AP1000 to ensure that the elements of construction are mitigated that could cause any delay. And that's removing some of the weather involved delays by the modularization approach, the tolerances, ensuring that we can deliver these modules on time through a qualified supply chain. It's an integrated delivery that has many aspects, and I think there's been many papers written on modularization in the oil and gas and nuclear, fossil. We all know the benefits of having predefined and built stair modules, building modules. So the intrinsic benefits are obvious for structural modules. And as we deploy more nuclear plants and keep the continuity of new build moving, we'll be able to even more so show directly the benefits of modularization in some of these key aspects of nuclear new build. I know that was a long answer to a short question, but I'll stop with that.
Rozumiem.
Thank you very much. Thank you for participating in our seminar. We're very pleased to have you. We hope that you will also accept an invitation to the next one. Thank you very much. And ladies and gentlemen, now we are connecting with our next speaker.
This is Ted Jones, Senior Director at the Nuclear Energy Institute. The title of the presentation will be The Role and Tasks of the Nuclear Energy Institute in the U.S. nuclear energy sector.
Hi, good afternoon. I want to thank the Ministry of Climate and the organizers for inviting me to participate in the webinar and compliment you for putting together such an excellent program. I'm honored to participate. My name is Ted Jones, and I handle international programs at NEI. NEI is the policy organization of the U.S. nuclear industry based in Washington, D.C. We have about 350 members, which include the whole nuclear value chain, from the owners and operators of the U.S. nuclear power plants to the plant designers such as Westinghouse and others, architect engineering firms, owners and operators of fuel cycle facilities, universities with nuclear engineering programs, U.S. national laboratories, and others. We also have international members. While our primary focus is on nuclear power operations in the United States, NEI also engages in bilateral and multilateral energy dialogues and promotes international trade of nuclear energy products and services on behalf of our members. This afternoon, I'll address a couple of important aspects of a nuclear supplier that Poland may consider as it plans for its nuclear energy future. First, I'll discuss the operational performance of the U.S. fleet. And second, I'll highlight the importance of a broad supply chain and a culture of innovation. And finally, I'll conclude with some thoughts on bilateral partnership. But first, just a little context. The U.S. has 94 operating reactors at the moment. That's down some from several years ago. But it's still much, much larger than any other fleet in the world. We also, account for a lot of the technology if you conclude designs based on U.S. original designs. And back to the United States, I wanted to say a quick word about public opinion and political support for nuclear energy here. As this chart shows, nuclear energy has consistently attracted strong public support for more than 2 decades. And this support is matched by political support from both Republicans and Democrats. And as we usher in a new government, you can be confident that nuclear energy, and in particular bilateral cooperation in nuclear energy, will continue with the full support of our government, just as it has in past transitions. In selecting a nuclear energy partner, it's important to consider operational expertise, industrial safety culture, and the regulatory experience, among other criteria. So I just wanted to share here a snapshot of what the U.S. fleet, how it has performed during the past year for which we have all the data. I mentioned earlier that we've suffered some setbacks with premature shutdowns, and I'll come to that in a moment, the challenges and how we're responding to them. But I wanted to start by highlighting some key numbers on the fleet's performance. Last year, the nuclear fleet, with fewer reactors than in previous years, nonetheless generated the most electricity ever and the highest capacity factor ever. We continue to account for about 20% of electricity generated. And you see here how the capacity factor has changed. It's been very high for a long time, and that is all about operational efficiency. Despite the plant closures, as I said, we've achieved an all-time high in generation. You see here that we've added since 1989 the equivalent of 32 new plants without adding more than the one at TVA since then. While we account for only 20% of the electricity generated, we are well over half of the carbon-free power. It's a huge amount, and I'll come back to this point in a moment. Just for perspective, that's the equivalent of 110 million passenger cars, what's been the emissions avoided. Also, excellent has been our safety performance, and that's achieved in the U.S. through layers of oversight. First, you've got the operator with its own protocols and procedures, and then we have review boards. Notably including the three here, in the orange band, and then only finally do we get confronted by the Nuclear Regulatory Commission, and our hope and expectation and usual result is that we've already exceeded those very high standards. You see here how the accident safety rate has improved. This is a result of rigorous training of plant workers and increased communication and cooperation among plants. And the U.S. supply chain now leads the world in its safety-conscious workforce training, its operational excellence, and culture of continuous improvement. I mentioned that we've had challenges, and we've got a number of them. We're generating all that zero-emitting power, but we're not getting the same compensation that renewables are in the U.S. We have had a low growth in electricity demand, particularly this past year, and a continuing surge in the supply of super cheap shale gas. We've achieved diversity in fuel in the U.S. Really by accident, and we could lose it because it's taken for granted. I mentioned the policies that promote renewables only. We have transmission constraints and market design issues as well. How have we responded? First, we've become more competitive. Since 2012, total generating costs in the nuclear fleet have been reduced by 25%. And I can share a detailed slide on this at the end if there's interest. Second, we've enlisted key communities who had not thought much of nuclear energy to take a greater interest in our future. For example, state and local governments have become more aware of the tax revenue from the plants. Labor unions have become more concerned and engaged to prevent the disappearance of jobs. And as we've heard in some of the earlier presentations, but yet to a greater degree in the United States, environmental groups have shifted to more open positions, at least some of them. And the environmental case is now transcending the NGO community. Companies like Google are driving industry-wide decisions about carbon pledges and utility generation. Google and other companies have highlighted the valuable role that nuclear plays today and can play in future efforts to decarbonize the economy beyond the power sector. Here you see in response to these commitments, the U.S. electricity generating companies have made their own commitments to reduce carbon emissions. And now they're realizing that they cannot get there with renewables alone. Even with life extensions and uprates, the current nuclear fleet can't achieve what's required. More nuclear will have to be built. So I wanted to say some things about the U.S. supply chain. The U.S. industry spans the complete life of a nuclear program. But what makes it unique, I'll go to this slide, is its track record of partnering in the development of national industries. Many nations that have partnered with the U.S. industry have successfully entered into the global nuclear supply chain. Some of these countries have become leading nuclear suppliers in their own right. And that is the best illustration of the US philosophy of technology transfer and localization. That philosophy is to work with you so that you can build the skills and capacity to successfully operate your own nuclear energy industry. Poland, with its engineering prowess and existing participation in nuclear energy projects, is very well positioned to take advantage of this kind of partnership. Building capacity is one of the first priorities for a new nuclear program, and the United States excels in human development at every phase. This chart illustrates for each phase the different kinds of training required, and at bottom, some of the organizations that are providing these development programs. Nuclear energy offers a nation more than electricity. It can also provide well-paying jobs, human development, and as I was just discussing, an essential part of the solution to global climate change. For this reason, innovation is another critical benefit of nuclear energy partnership. This diagram depicts a timeline of US innovation with some examples. On the left are the AP1000s in the United States. I think they're 94 and 88% complete now. The AP1000 should be on there earlier, given that they've been already operating in China. And for the large-scale power required by Poland and many other nations, this kind of plant is the present and the future. For other needs, the US is bringing to the market a range of innovative designs, from SMRs to advanced non-light water reactors and more. At last count, there are 64 private sector advanced nuclear projects in the United States, ranging from academic research projects to designs close to commercialization. Here, the AP1000s operating well in China, about which Mr. Weir had some things to say. And there are 5 companies actually already working with the NRC to prepare for licensing SMRs. And these are just a few examples. NuScale is out in front as the world's first and only SMR to gain design certification approval by the US NRC. And here are some examples of non-light water cooled reactors. The Department of Energy has been very strongly supportive of these next generation designs. And here you see an outline of the Advanced Reactor Demo Program, which just made its demonstration awards to TerraPower and X-Energy in the amount of $3.2 billion. The new designs have broad applications not limited to power generation, which are necessary to decarbonize our economies. Poland and the United States have already cooperated in advanced nuclear energy projects, and as our commercial partnerships deepen in the development of large plants, one can expect to see cooperation in the next generation technologies expand as well. So I'll close with just a few observations. Nuclear energy cooperation is a long-term strategic endeavor founded on mutual trust and respect. And I think US nuclear cooperation offers some unique benefits here. I shared some of the record in industrial partnership, technology transfer, and localization. We also have operational expertise with the world's largest fleet of plants, an outstanding industrial safety culture, collaboration with the US NRC and US National Laboratory Complex usually results And world-leading programs in nuclear science and engineering naturally become more available when the commercial partnerships progress. It's a century-long relationship with implications beyond the power sector. So it's important to have shared values and interests. Poland and the United States share this foundation today, tomorrow, and 100 years from now. Thank you, and I'm happy to take any questions.
Dziękuję bardzo.
Thank you very much. Thank you very much for this presentation. Of course, I do have a question. Actually, to this last item, the $3.2 billion, this is the amount you gave on one of your last slides. It might be an abstract amount to us here, but it's of course no secret that the US administration spends a lot of money to develop the new technologies for nuclear power. This is also something you said, but could you please say something more about those activities and tools that are generally used in the US when funding research work, so that you are able to commercialize those projects on a fast lane? Could you please share more details?
Well, I'll try. We've got a number of colleagues that work on this all the time to support our members. The Advanced Reactor Demo Program is just one of the Department of Energy's many programs that support nuclear energy, as you know, and just one of those that supports nuclear energy development and demonstration. There is an ARPA-E program that was established several years ago, from which has emerged a number of the private sector advanced reactor projects that I referenced earlier. The Advanced Reactor Demo Program is a more specific program to construct these plants in the United States so they can be demonstrated in their commercial potential. And there's other programs that have supported the NuScale and reactor, which is already has a customer now in Idaho, and will be constructed in the coming years there to demonstrate that design. If there's something specific, then I can try to address that, but that's just an idea.
Thank you very much. This was our last foreign speaker. Thank you very much. I'm so very happy to have had you here today with us. I'd like to invite you to our future seminars, of course. And now, before we move over to a short summary, in a moment we are going to listen to the last presentation prepared by Bogdan Pilch, the General Director of our chamber. And this will be a presentation about the implementations of foreign nuclear projects by Polish companies. Bogdan, the floor is yours. Welcome once again, ladies and gentlemen. I think many people are tired, and I will try to present the involvement of Polish companies in the execution of the nuclear program in Poland. Ladies and gentlemen, there will be a time for a summary, because right now some of those elements could already be included in my presentation. Nevertheless, I will try to very quickly go through the slides that I have prepared for you. And then there will be a short, brief summary. Ladies and gentlemen, who are we? I don't think all of you know our chamber. This is a self-government organization that was created in 1992. Right now, there are approximately 100 member companies, and as you can see here, those are companies from the entire broadly understood chain in the broadly understood energy sector. Those are Energa, Enea, PGE, Gieksa, Orlen, PKN Orlen, who have this will become the Poland's biggest multi-energy company. We have famous and recognized suppliers of equipment manufacturers, including such famous companies as GE Power or Siemens Power System. We have recognized companies that are manufacturers of devices, but we also have contracting companies and engineering companies like Polimex Mostostal or Energoprojekt Katowice or Energoprojekt Warszawa. We have companies that provide services, overhaul services, consulting services, legal services. We also have a company that operates in the translation industry. This is today's partner of our event, Bireta. So we are an integrator, a business integrator throughout the entire chain connected to the power industry in Poland. Now, moving over to the topic at hand, ladies and gentlemen, in this slide, you can see the potential areas where this so-called own share, localized shared, local content, as the English call it, might happen when you execute a nuclear project. And it should be stressed that virtually this entire involvement from those companies results from the experience of those companies in foreign markets and when implementing nuclear projects. It was already mentioned I think it will be mentioned in one of the following slides that we can identify some 300 such companies. But moving over to a particular project where we already have areas that those companies can use to implement their knowledge and experience, then looking from the bottom up, from where we have the simplest work, we can see that in those areas, actually, Polish companies can be involved in the full scale of the project, both at the design stage, manufacturing components, and the OMM, the operation and maintenance phase. Here we have red dots and black dots. Red dots actually mean that we actually don't have companies that could operate to execute the first project. We are talking more about executing follow-up projects, experience that would be acquired. But generally, moving up this pyramid, you know that these are more and more specialized works that require special skills, certificates. Also, if we're talking about margins, there are high margins involved here. So here I can see large potential for companies changing their primary industry, which will also result from the fact that in Poland right now, most companies operating in the energy sector focus on traditional energy, on conventional energy. We know perfectly well that policy and its direction of change there will be less and less such works. We can actually rule out the construction of any new coal-fired power plant. There will only be only maintenance works will be left. So in my opinion, a lot of companies will be forced to diversify its operations in order to stay in the market. Here I'm showing you a slide that we received in cooperation with the ministry that carried out an analysis of the competences, of domestic competences in terms of getting involved in a nuclear project, and we created a gap analysis which showed that there is a potential, as was mentioned, almost 30 companies, and some of those companies already have such competences that they don't need anything more virtually, they don't need anything virtually else, or they require either simple or other adjustment works to meet those very stringent requirements that were discussed in so much detail today, those standards, norms, or certificates that are necessary. One of the important elements here, in my opinion, is the government policy within the scope of the share of this involvement at the national level in production. And there's a lot of talk about the fact that with the first facility, the first nuclear facility, it should be at least 40%. And as we execute additional projects that result from the Polish nuclear industry project, we're talking about those 69 units, between 6 and 9 units, we assume that this share will be growing. Ladies and gentlemen, there's a parallel here, a very similar situation to what we have in wind power, offshore wind power, where also
inwestycji polskich i również zakłada się bardzo znaczący udział.
There's a very ambitious program for Polish investment, and we are assuming a high share, high involvement of Polish entities there. They are trying to do it as in the form of implementing such provisions in the act that is currently being processed. As far as the experience of Polish companies, in those big projects, perhaps those were not projects at the scale of a nuclear project, but still, if we look at Opole or Kozienice or Jaworzno, these are considerable amounts. And here, Polish companies were EPC contractors, so turnkey contractors, as was the case with many projects. This was mentioned already in many presentations today. There are always unforeseen risks, turns of events, problems with some of those projects. We also had, I wouldn't like to go into details about this. Generally, there has been a lot of potential here, and there's a number of companies that would like to get involved in such projects, perhaps not as the main contractors, but as subcontractors. Here we have collated examples of companies from various scopes, various industries that already have on-the-ground experience. We are talking about manufacturing components, suppliers and vendors of subsystems, equipment. We have listed companies. You will see this presentation. I wouldn't like to spend time on discussing this because we are nearing the end of our time for this presentation. So you can see there's a lot of potential in a number of markets, and it has been potential for many years. The same goes for works, construction works, where you might say that it seems that I can't imagine Polish companies not getting involved, not getting on board with that, because we have a number of very meaningful companies. They have experience, and this experience is not only in the construction of
w dawnym RWPG, ale również dzisiaj
nuclear power units in the old Soviet countries, but also power units right now in Finland. So a list of those companies provided here. We're sorry if someone was omitted, but it's, so to say, just for presentation purposes on the potential. This is a more widespread perspective. We're showing this on the map, how it works. You can see that this is a considerable part of the world, perhaps except for South America, Africa, Australia. Then Polish companies were actually involved in a lot of projects. Those are 24 countries in 3 continents. And this is not only involvement in nuclear projects, but we're also talking about projects related to life extension, some projects that are related to the decommissioning. So we are talking about projects that simply take a power plant out of operation, also for the works related to maintenance and overhaul. Then you could see the Baraka project in the United Arab Emirates, where actually the full reactor power was started, and there are several Polish engineers working in very important positions as employees for various contracting and subcontracting companies. So we can see an enormous potential here. And ladies and gentlemen, what are the main goals and tasks right now? What needs to be done? A lot was already said today. I will just reiterate this goal, this 40% goal that the government is putting forward for the first stage. And this is where we assume the learning curve or the lessons learned, as the English say. So we are assuming that experience accumulated in the execution of the first project will be reflected in an increase of this domestic component. I'm not trying to guess whether this would be 50 or 60%, because this is not what this is about. We want this share to be at its maximum, but still, for this share to be maximum, we need to meet a number of conditions, and this was also stressed today. We need to have a very active role of the government. In dealings with the Polish industry, this should be an activity that it should not be waiting for the moment where those investment decisions are taken. This was stressed. We need to prepare for this. You can do that through various forms, seminars, missions, trade missions, transfer of technology to Polish companies. This meeting like today is for this purpose, so that we understand that there's an enormous potential, there are possibilities, there are opportunities, but on the other hand, nothing is for free, and without a discussion, you need to get involved. Here, of course, companies want or would like to get support for certificates, for standards. I think we will probably be seeing some money spent on that. There's a lot to be done here, and if we add support and if we add promotion for Polish companies in foreign markets for them to win contracts, this might also result in this not only being the Polish market, but also foreign markets. So this is where I would like to stress that what many people have been stressing, and the lady also stressed this today, that all those activities should be implemented at the earliest stage possible in order to maximize the involvement of Poland in the nuclear program. And ladies and gentlemen, still to wrap up, I would just like to stress that we as the chamber, we are ready to support companies. Here I showed you member companies who have been our members and our active partners in the market, and I also hope that they will continue being those partners in the market, players in the market, in Polish market. Nevertheless, regardless of whether you're our member or not, we are ready to support you, and we also hope to cooperate with the government, with the Ministry of Climate, because as I said, there's a lot of work to be done, and this needs to be done in a way that is coordinated. What was already shown in many presentations here, so just your will is one thing, and how you do it, with whom you do it, it's also very important. So this is the end of my presentation, and ladies and gentlemen, to summarize, because I know that this was a tiring day, I think that this was a very fruitful day. First of all, I'm happy that despite this formula, that despite the fact that almost all of our guests were here remotely via the internet, and also we had simultaneous interpreting, I think that there were no big problems. If there had been any, I'm very sorry that you had to witness it. All the people involved, including the technical team, Agnieszka, the host, I would like to thank them all a lot. I'd like to thank the interpreters too. I realize what strain and what difficult work it is. To the technical team, also a big thank you. And for my summary, I will just say that today's meeting, the conclusions are that, in my opinion, there's a lot of support available for nuclear projects, not only in Europe, but also we can see it in the US and in Korea and other markets. So a lot of people have anticipated the advent of nuclear energy. This was the problems that appeared after Fukushima and the German decisions. Actually, the Green Deal caused that the power industry, the nuclear power industry, is becoming an indispensable element to supplement the growing share of RES, especially those non-controllable sources, as I call them. So from that point of view, from the point of view of the business justification, surely there are no obstacles. Under the Polish conditions, what is very important right now is to find a consensus, to find a broad political consensus. Right now, virtually no one negates the need to build a nuclear power plant, but there is also social support, there is also community support. Recent polls have suggested that more than 50% of the responders support this project. From the business perspective, this is also something that will stand the test of time. This depends on what assumptions you take for your financial model, what costs you consider, because also what time perspective you take. So the 60, 80 years, zero emission sources, a stable source. So in my opinion, proven technologies available today, so we don't need to think about those risks. So practically speaking, those are just business decisions, and as I said, in those three main aspects, selecting the technology, selecting the partner, selecting the method of financing, and what it seems to us is very important, what this conference was devoted to right now, is support for the Polish industry, is support for, it cannot be only the government, it cannot not be only be the industry cannot wait. Also, this shows that some action needs to be taken. Of course, it entails some cost and some people, but just show me those projects that you can execute without risk and without cost. So thank you very much. I hope that we will repeat such events, such conferences under other conditions. So post-pandemic, this is surely a big difficulty for all of us, and this receipt is also quite different. If you meet in person, if you meet live, it's a completely different experience. But today, for the above mentioned reasons, we were limited. Thank you very much to all of you for your attention. Have a good day, have a good evening. See you next time. Bye.